See, in every field, there are some very fundamental things. Like if I take the example of mathematics, that will be algebra. Okay, for physics, it will be mechanics. Okay, for medical science, it will be anatomy. You got the idea. Okay, in the similar fashion, if I take the IT industry, if you are a developer, if you are a automation tester, system admin, DevOps, data engineer, data scientist, whatever maybe you are, there are a couple of things that are very fundamental, very necessary. And one of those fundamental skills is this command line interface or CLI. Okay, and many beginners does not even know like what's a command line interface, and you maybe know this black screen, right? And some of you attach this black screen with Linux only, but it's a feature of your all the operating system, you can say. So let me tell you a story first. So at the beginning of my career, I wanted to learn Ruby on Rails. Okay, so there is a programming language called Ruby. Maybe you know this. Okay, and there's a framework like nowadays, Next.js is a framework, Fast API. So similarly, Ruby on Rails was a framework, and I wanted to learn that. Okay, so at that time I didn't have any experience with command line interface, and I kind of bought a course, or I was watching on YouTube. I don't exactly remember. No, I did buy the course, I guess, um, from LinkedIn. At that time, LinkedIn Learning was the new thing, and I kind of purchased a course on Ruby on Rails, and I have started the course. And the first thing that the instructor did is, nowadays, if you're coming from a, let's say, React background, you do create React app or next in it, or you scaffold all the initial boilerplate code, right? And that Ruby on Rails instructor did that for Ruby on Rails. Like he ran some command and it generated some codes. Okay, and I was kind of super scared. I'm like, no, I don't know these things, and I didn't able to convince myself to continue with Ruby on Rails. I didn't, and for me, I'm like, if I do not understand the first basic thing, then I won't be able to continue with that part. Okay, so if I am learning anything complicated, I have to first like recreate the complicated thing from that basic. For example, let's say if you ask me to understand calculus, okay, when I'm learning calculus, I would rather first derive calculus from the basic number theory. And if I can only derive calculus from basic number theory, then I will go into the calculus. Otherwise, I won't, like my brain wouldn't register that. Okay, so for that reason, I kind of completely dropped my idea of learning Ruby on Rails for this command line interface. And also I delayed learning Git as well. I delayed everything, like whatever technology I was having. Somehow I had to interact with the command line interface, and I did everything to avoid that. So yeah, for that reason, couple of years back, I did a lot of research because I was running an YouTube channel, right? And I wanted to create a course on command line interface or CLI mastery, right? So I thought, like, let me create a roadmap on how you should learn command line interface and what are the basic topics that you master, and how how can I connect, like from the history. Like whenever I'm teaching something, I try to connect that from the history, from starting from the why did we need command line interface, why that was got introduced in the first place, right? So in this course, my target will be beginning from there, starting from there. And yeah, I'm calling this CLI mastery. So let me type that as well. So I can guarantee you, if you go through this course, you won't get scared about around command line interface anymore, right? Maybe you won't memorize all the commands nowadays. Also, I like, if I need any complicated command, I just Google that, and or I ask the AI and I copy paste the command in my command line interface, right? But then also I understand that, okay, this is flag, this is the argument I'm passing, this is the actual command. But I do not memorize those things. But similar things will happen for you as well. You will understand the entire thing, but you won't memorize. You will still copy the commands from somewhere else, maybe. But some of the very frequent command you will memorize, obviously. Okay, so this is my target with this video lecture series, you can call it. So yeah, let's get started. Alright, so in this video, we'll be discussing about the history of terminal or command line interface, and we'll be understanding why this is particularly called terminal. So this terminal word, basically, like you are familiar with bus terminal, right? Bus terminal, train terminal. If you want to access the bus, you have to go to the bus terminal. This terminal word has the similar meaning, and if I go through the history, you will get to know like why this is called a terminal. And also it is called CLI or command line interface, and terminal and interface are kind of interchangeable. Okay, so you can call it like a bus station, or bus terminal can be called as bus interface as well, right? So let's understand the history. So back then, I'm talking about, let's say, 1950s. Okay, so around 1950s, like during that days, computer were big and bulky. Okay, so there are no concept of personal computer first of all, and large universities and government bodies might have some computers, right? And all the machineries and everything you had to store in a large room. Okay, and there was a separate technician and multiple technicians maybe to handle this computer, and like there is no concept of programmer directly interacting with the computer. So let me give you a situation like how at this period of time how people were using computers. So let's say in a large university you are a professor. Okay, you are a maths professor, and you have a bunch of students, and they have their marks. Okay, and you want to generate grade cards for these students. So to generate the grade card, you want to use this computer. Okay, so this is the problem statement. Now back then, there is no concept of like keyboard and mouse. There is no input device. So there's a thing called punch card. Okay, so if I go to Google and search for punch card, so this is a punch card. Okay, so this professor had to write punch card for each individual student. And so let's say if you are having 100 student, you have to punch 100 cards, right? And finally he will hand over this card to this technician. So this is the input, and technician will go to the computer. He will set this punch card. Okay, and he will run the computer, and this computer will give back the grade card, and this technician will give this grade card back to this professor. Okay, now there might be a case that for these students, this professor has entered the punch card incorrectly, right? This student, maybe five other student has like different value in the punch card. Okay, so there's an error in the program, you can say. So the professor has to go through the process again. Okay, he will prepare the punch card again. He will get back to the technician with the punch card. Technician will run this punch card again through the computer, and it will generate this grade cards, right? Now in the previous days, like everything was processed, like this punch card was processed in batch operations, right? So you cannot just go to the technician with a single punch card or a 5 or 6 punch card and ask him to run it through the computer, right? This technician will wait and collect many more punch card before he will input those punch card in the computer. So these are all the drawback that this system had, right? So basically the first drawback was there is a middleman. So you had to go through a middleman to access the computer. All right, so this is the problem. Now around 1960s, they have actually solved this problem by introducing a thing called terminal. Now this is the terminal device, and it is composed of a screen, okay, where you can see like whatever commands you are entering, and the output from the computer, right? And for the input device, they have used some sort of keyboard kind of mechanism. So now you don't need any kind of punch card, and you don't need the technician as well to talk to the computer. Okay, so you are like completely removing this middleman, and as the input device, you can just use your keyboard. Now this professor, if he wants to like generate the grade card for a particular student, he can just enter the number here, okay, whatever marks that student got, and this command can directly travel into the computer, and computer can process that data, and it will output that data in the terminal. Or like if this computer is connected to any kind of printer or any device like that, like let me just type printer here, it can directly print out the grade cards. And in real time now, this professor can see like if he has any kind of bug in the program or in the logic, he can like identify that from here, from this terminal. So basically this is the concept of terminal, and the terminal was introduced to actually talk to the computer. So you cannot directly access the computer, but through the terminal you can access the computer. Okay. And if this is a mainframe computer, let's not go into the mainframe part, but yeah, if you are having a mainframe computer, then you can have like multiple terminal. Like let's say this terminal is used in the maths department, and you can have another a terminal, let's say for the chemistry department, okay, which is using the same computer hardware. All right, so this is the concept of terminal, and why this was introduced in the first place. And after a couple of years, they have introduced a new technology called mouse. And after inventing this technology, they have actually created graphical user interface. So with the help of this mouse, now you can point into different things and click around and like do certain things. Okay. All right. Now we are familiar with the terminal, and terminal are basically physical devices like printer or monitor, like that, right? And this is our computer, and these are all the computer hardware like hard disk, motherboard, and all those things, right? And from this terminal, you are prompting different commands, right? Like show me all the files, delete this file, remove this file, those kind of command. And as you already know, like computer only knows binary, right? So, and you are writing this command in plain English maybe, so you have to compile this English language or English command into binary code, right? So for that reason, there is a special kind of software we use. Okay, so that is called a shell. All right, so let me just create a shell. So shell is like eggshell, is it's the outermost layer. Okay, so if I can, yeah, create a shell. So shell, so on top of your hardware, you will be having a kernel. Kernel is the lowest layer of operating system. You don't have to like understand the whole concept of kernel operating system. I'm just telling you all this just to give you a feel. Okay, so yeah, on top of the kernel, the outermost layer is the shell. Okay, and you are connecting to this shell from your terminal. Okay, so terminal is a physical device that you use to communicate with the computer hardware through the shell. Okay, and whatever command you write in English, this shell will convert those command, so this hardware can actually understand those commands, right? So this is called shell. So the two things that I need you to remember from this video is terminal is a physical device. All right, in previous days, not nowadays, terminal is a software as well, and I will be showing you that. So in previous days, terminal was a physical device, and basically like they didn't have a keyboard. They were using typewriter machines, and these were CRT monitor, I guess. So yeah, this combination of these two would be the terminal, and this terminal will be connected to the outermost layer of the operating system, that is called a shell. So from the terminal through the shell, we can operate, or we can pass different command and see the output from the computer. All right, so we can show this diagram in a different way. So as we have already discussed, the outermost layer is called the shell, and shell is sitting on top of the kernel or the operating system, and the operating system is controlling the hardwares. And in previous days, as we have mentioned already, terminal was a physical device. Okay, you were using typewriter and maybe a CRT monitor, and combining these two, you were creating a terminal. Okay, nowadays inside our personal computer, we have terminal emulator. Okay, so right now I'm on a Mac, so let me show you the terminal emulator for the Mac. So let me search for terminal. Inside Mac, the terminal application name is terminal as well. Right, so this is kind of a window, and by default, I guess this is the background color is black, and you can obviously customize these things, and I will be showing you all the things, right? And yeah, let me just increase the font size a bit so that you can see properly. Right, and right now whatever I'll be writing in the terminal, don't worry about that, you will be understanding once the course progress, right? So these are some information. and let me just type a command called ls. Okay, so when I'm publishing this ls command, so from the terminal I am entering ls, and ls is going to this shell. Okay, so inside this terminal a shell is running. Okay, so for Mac right now I am on G shell, and I will introduce many more shell, and we'll be learning different kind of shell for different operating system. If you're coming from a Windows background, then you are already familiar with PowerShell. Maybe you have heard of the term PowerShell, right? So whatever command I'm writing here, it is transferring that command to the shell. Okay, and shell is interpreting that command, and it is sending the appropriate instruction to the kernel or operating system. Okay, and the operating system is like ALS is basically like listing all the things, all the directory, all the files present on the file system path. And yeah, we'll be understanding about ls command in a great depth. Don't worry about that. So yeah, this current operating system is saying like in this particular path you are having this content. Okay, and it is just giving you the output, and the shell is forwarding the output onto this screen. All right, so this is what is happening under the hood. All right, so in the next video let us understand like what are different kind of terminal emulator software in different operating system, and inside those emulator what are the shells you will be able to use. Okay, all right, so in this video let us discuss like according to your operating system what are the terminal emulators options you are currently having, right? And I'm just showing couple of those, and some of those applications are installed by default, and you have to install a couple of those from third-party libraries maybe. And there are many other terminal emulators present in the market. I'm just showing you the like famous one nowadays, right? So for Windows, this is the basic one. This is this comes with the Windows. This is called command prompt, right? Then you are having PowerShell for Windows, and nowadays they have a system called Windows subsystem for Linux. Okay, and I will be showing you in upcoming videos what are the difference between these three. Like do you want to use a command prompt, PowerShell, or WSL, right? And this is a third party one, Git Bash. Maybe you have heard of this term. And yeah, this is like you have to install separately this Git Bash on WSL. Also you have to like install from their like Windows App Store, I guess. And for the Mac there is a terminal app by default that I have already shown you, right? And item 2 is third party again. You have to like manually install this. And for Linux there are many options. Genome Terminal, Xterm Console are some of the like famous one, you can say. Right, so these are some terminal emulator options. Now let's see like on these terminal emulators what are the shell we are running, right? So already you know like this is the terminal, and inside this terminal we'll be running a shell, and through the shell we'll be talking to the computer, right? So for Windows command prompt, the shell name is also command prompt. For PowerShell they're using PowerShell, and you can see like shell is in the name as well. And then comes the good stuff. So Windows subsystem for Linux, this use bash. Okay, and we'll be learning a lot about this bash on. Okay, and Git Bash also use bash, as you can see from the name. And inside Mac the terminal app is using G shell, and nowadays they are using G shell, but previously the default shell was bash. And if you want you can use many other shell as well. For item 2 we have the similar situation, right? And for Linux systems as well, like whatever shell you want to use other than this command prompt and PowerShell, you can use whatever shell you want, like bash, G shell, corn shell, K shell. There are many shell. Okay, I will be showing you those, and throughout the course we will be using this G shell or bash. Okay, these are like pretty similar, like whatever topic we'll be covering in this course, like you won't find any kind of difference. So if you want you can follow with G shell if you are having a Mac. Otherwise if you are following along with a Linux system, then bash is fine. For Windows I will be showing you like you have to install Git Bash or use this Windows subsystem for Linux. And the next video I'll be explaining in details like what are the difference between this command prompt, PowerShell, and what is this bash, and why do we want to use bash other than this PowerShell. Okay, so let us come back to the next video, and let us discuss about these things. Right, so in the last video we have discussed that for this course we'll be using terminal app from Mac, right? And the shell will be using bash or G shell, right? Now in this video I'll be explaining why this is the decision and why are we not using any kind of Windows system or the default shell that is coming with Windows like command prompt or PowerShell, right? So let us go back to the history. So I will be discussing a timeline. All right. So around 1950s, as we have already discussed, that around this time the main input devices were like this punch card and magnetic tape, right? So punch card based computers, right? And computers are big and bulky at that time. You can see here, right? Now, these days, around these days, the main problem was like the operating system that were used to run on this computer. Those were kind of hardware specific. Now, if I give you an example, let's say in today's scenario, let's say ASP is building its own operating system, Dell it's building its own operating system. It's kind of like that. So to solve this problem and to make a portable or generalized operating system, around 1969, these two legend, this is Ken Thompson and Dennis Ritchie, right? In Bell Lab, they have invented Unix. So Unix has kind of changed the like course of computing industry. Maybe you have heard of this Dennis Ritchie guy, right? He is the inventor of C programming language as well. So in 1972, he invented C to write Unix. All right. So Unix was born, and then around, let's say, 1980, 1990, around this time, this was like personal computers time, right? Like when Unix was invented, around this time also, like computers are used in like military facilities, universities, or like large businesses were using computers, right? But around this time, graphical user interface were introduced, like I guess 1984 first Apple introduced graphical user interface, and then Microsoft kind of copied that in 1985, I guess. Yeah. So these were the era of personal computers, right? Now this Microsoft was coming from an operating system called MS-DOS, Microsoft DIX operating system. So this was kind of similar to Unix. Like you didn't have any kind of graphical user interface in MS-DOS as well. You just had a terminal and through the shell you had to communicate. This was built for IBM PC, I guess. But the main thing was MS-DOS was much less powerful than Unix. Okay. And Microsoft, the graphical user interface that you know now, that Microsoft was built on top of this MS-DOS. On the other hand, this Mac OS was built on top of Unix. So there's a version called BSD Unix, right? Let's not go into the like details of BSD Unix, but yeah, Mac OS was built on top of BSD Unix, and there's another operating system called Next. So by combining those two, Mac was invented. All right. So this was the era of personal computers and graphical user interface, right? Now around 1991, there's a guy called Linus Torvald, right? So he had a problem. The problem was he didn't have enough money to buy this Unix operating system. Like this Unix operating system was built for businesses, right? If you have a large amount of money, then you could afford Unix. Okay, so you had to pay a large amount. So what Linus did is he completely rewritten Unix, like exactly, okay, almost exactly, and he made it open source, okay, and called it Linux. And as he made it open source, many developers around the world could contribute to the operating system, right? So that is how Linux is born. So you can see from this discussion, like Mac OS and Linux both are sharing same Unix environment, like both are generated from Unix. On the other hand, Microsoft was originated from MS-DOS. Okay, I'm not saying Microsoft is bad, but Microsoft was basically built for graphical user interface and for non-technical people, I should say, right? So let's say you are just working in Excel file, or you are just using those Office suite, Microsoft Office, Microsoft PowerPoint, those kind of softwares you are using. You are working in a banking system, you are working in a maybe airline industry. For those kind of situation, Microsoft is a like very good choice. Okay, but as a developer, as a data engineer, as a cloud engineer, or like any kind of, if you're doing any kind of programming, or you are interested in the low level things, right, or you are building different kind of softwares, then your best choice would be Linux and Mac OS, and both shares the Unix system. And if I'm talking about any kind of devices now, like Android is using Linux, right? Like whatever operating system is used inside your car, inside your even your microwave, that is also Linux. In the cloud computing industry also, like hosting and all those database things and everything, you are using Linux as well. So for that reason, it's a very good idea to stick to Linux and Mac OS if you are building things. And the default shell that Linux and Mac OS is using, that is coming from Unix, right? So there's a shell called bash or Unix based shell, any kind of Unix based shell, right? So both Mac OS and Linux supports that. By default, inside Linux, the shell is bash. Nowadays, Mac OS uses G shell, but that is also bash kind of. On the other hand, Microsoft is using like a command prompt and PowerShell, and that's the reason for this course we are choosing bash, not any kind of PowerShell or command prompt. So I hope I have convinced you to use the bash shell. So yeah, if you are inside a Microsoft environment, I would suggest, if you can, shift to Linux or Mac OS. Or if you want to stay with Microsoft, then use git bash inside Microsoft, right? So that when you are configuring anything for the cloud or any kind of servers you are dealing with, that would be much easier for you to navigate around and understand what the hack is going on under the hood. So for that reason, for our course, we will be using this terminal app, and we'll be running G shell, which is also almost similar to bash. So I will see you in the next one. Say guys, this is the first section of my entire full course, CLI Mastery, right? And in this video series, I am covering the basics only. That will get you started. Now you have two options. If you want to learn more, you can ask ChatGPT whenever you are facing any difficulty, or you want to learn the advanced concepts as well. You can ask AI, Google things, go through different documentation. This is the option number one. Or you can purchase the full course. I will mention, like, the link is mentioned in the description as well, and there you will find some more advanced concepts as well, like what is shell scripting, how you can, there will be some hands-on as well. But yeah, to get started, this is enough. Okay, but if you are feeling like that I have already completed the starting section, and I do not want to do my research from my side, I want an structured approach, yeah, then you can consider this course. Okay. All right, so let us actually open our terminal window. So terminal, and let us just write some command to get a feel like how things are working, right? Now these are some of the information that it will give you, and it's obviously configurable. It's giving you the date, time, and this is the ID for this window, right? You can open multiple terminal window. So I can just press command N in my system, and it will open another window. You can see this ID is different, right? Let me close this one, and yeah, so this is called a primary prompt, right? So if you write any kind of command, new command, before that, like I'm writing this like gibberish command and hitting enter, so it is like giving me some sort of output, right? After that, again you can see this prompt, primary prompt, right? So you can, this is also configurable. Like right now it is just showing me my username at my machine name, I guess. All right, so let me just clear my window. Okay, if you type this clear thing, this will clear your window. Okay, and let me write who am I. So this who am I command will show you the username that has been used to log into this terminal window, right? And there's a big section in this course where we'll be covering like what is user, what are groups, what are different kind of permissions, right? But yeah, who am I command will just give you the username, right? Now if I just type who, it will give me like for this particular user what are the login information. So this is this session, like for this terminal window, and you are already familiar with this ID, I guess. And when I have logged in, okay, and this is the console is basically you already know this graphical user interface also uses some sort of shell to communicate with the kernel, right? And the first one is basically my graphical user interface, right? So whatever processes I'm running for my graphical user interface, this is that. And this window, this terminal window is this one. If I open a new one, right, and type this who command now, you can see I have 3. Okay, let me quit out from this one, and if I type the who command now, again I'm just having 2. Right. Again, let us clear the window, and there's a command called echo, right? Echo, and you can just type, let's say, hello. So this echo command is whatever argument you will be passing to this echo command, it will give back you that string. Okay, so I'm just passing hello, and it is just printing hello in the terminal. All right. And when you are running any kind of command, if you are having space in the argument, then it's a good idea to wrap this inside a quotation mark, right? So echo hi there, and it is giving you back the hi there. Now to navigate around, you can use the left and right arrow in your keyboard, right? And there is another shortcut, that is if you press Ctrl A, that will take you to the start of this command, right? And if you press Ctrl E, this will take you the end of the command. Okay. And also another thing I want to show you here, let's say I'm just writing EC and then hitting tab, right? It is completing, auto completing the whole thing for me. So you can just write the first one or two character and it will auto complete the rest of the things for you. Now we got a basic idea like how commands are working, and what is the primary prompt, and how you are giving different command as a prompt. Now once you are done with this terminal window, you can just type exit, hit enter, and you are exiting out of this window, right? And it's showing you process completed. All right. So yeah, now you cannot write anything. This is a dead terminal now. All right, so in this video, we'll be discussing about the structure of different Unix command, right? So this is the general structure that like almost all of the Unix commands follows, right? First, you will be typing the command. Then if you are passing any kind of option, that, and then the arguments. So if I give you an example, in the previous video, we have seen this echo command, right? So this is the command name echo, and then you are passing the argument. For this echo command, we are not passing any options yet, but yeah, I'll be showing you that. So echo hi there, right? So it is showing hi there in the console. Now let us pass an option with this echo command. So echo dash n hi there. So now this character means this is the line end, right? Nothing is after this e character. Okay, but if you do not pass this n option, then there is a new line. Then there will be a new line printed after the like whatever you are asking it to echo. Okay, so this is the command structure. First you are passing the command name, then the option, and generally if you are passing the option as a single letter, then you will be mentioning a single dash. But if you are passing the option name as a word, then you will pass a double dash. Okay, let me show that. So let's say there is a Unix command called make. Okay, so we can pass this dash v option that will show you the like version number for this particular command. So to get the same information, we can do it like this as well. Dash dash version, right? It is giving us the same thing. So what I'm trying to say is, if generally, in general, if you are just passing a single letter, then you are using a single dash. But if you are passing a word, then you will be mentioning two dash, right? So let me clear out. Let me show you another thing. I can actually mix and match different options together, right? So there's a command called ls. The thing is, whenever you are opening your terminal, we'll be discussing this in great detail in the upcoming videos, right? But the thing is, you always open your terminal or shell in a particular location, okay, particular directory, you can say. So right now I have opened my terminal in the desktop directory, right? And to know about that, if you publish this command, this pwd present working directory, it will tell you. So inside users show on, and this is my desktop. I'm on my desktop, and you can see from the graphical user interface, I have a couple of files and directory present here, right? So let me clear out, and there's a command called ls. Okay, ls is kind of short for list. Okay, so ls will basically show you like what are the things present in the current directory. Okay, so you can see directory 1, directory 2, file 1, file 2. All right, and I can pass different option to this ls command as well, like ls-l. So this will list out all everything. Okay, so you can see I'm getting a lot of information. Right now, these are some I will be understanding like what does this mean, and also the owner of this directory is this user, and this user belongs to this group. Okay, we'll be learning about users and group in great details as well. And this is when the directory was created, and this is the size, and you can see this size is 64. Like I don't know what 64 means. So if you pass this option, like this dash h, it will give you the human readable format of this file size, right? So let's see. So now it's clearly showing you like this directory size is 64-bit. You can see I'm passing these options one after another, right? So what you can do is, first of all, I want to mention that this order does not mean anything. You can just like mix and match this order. So I'm getting the same thing. And what you can do is you can pass this option together. So you can see I'm putting a single dash and then L, then H. Okay. I'm getting the same output. So let me clear out. So ls-lh. Perfect. So I'm getting all the directory and files that are present in this particular location. So from this video, we have understood that inside Unix, you first mention the command. Then if you want to modify this command in some sort of way, then you are passing any kind of option and you can change the order or pass the options all together. And finally, if this command is taking any kind of argument, you can pass that. And one more thing is this option can take options, right? So let me show you an example. So there's an interesting command inside Unix that is called banner, right? Banner is basically, let me just write a text and it will you will understand. So banner hello. So you can see with this hash, right, it is printing hello. And now this is kind of like super zoomed in way, so we cannot like read it, I guess. So what I can do is I can pass an option with this banner command. So banner dash width, and I want to mention the width of this banner. Okay, so let's say 30 hashes, and now the argument is hello. So in this particular command, okay, let me just first run this command. So now you can see I can print hello. So now in this particular command, what is happening is I'm writing the command, then this is the option, and this is the argument for this option, and then I'm passing this argument for this command, right? And it should make sense, right, that I'm asking this banner command to write hello, and the width I'm passing is 30 pixel maybe, or 30 hashes, right? And if you want, you can remove this space from here as well. So let me show you. So if I remove this space and hit enter, I'm getting the same thing. Now let me show you with a particular command. If this command accepts multiple arguments, we can pass different multiple arguments together, right? So there's a command called cat. This is short for concatenation. And cat is basically like if you run any file, text file or anything, it will like preview that file, right? So cat, and you already know we have a file1.txt. So let's see like what are the things present here. By the way, I'm pressing tab to autocomplete, right? So if I just type if I and then hit tab, it's completing till this dash, right? Now it does not know like do you want 1 or 2. So if you hit tab again, it will give you these options, right? And if you keep hitting the tab, it will like circle through those options, right? So we want to see the content of this file1. So you can see in the file1 we are having hello there from file1. So if I double click on this file, you can see this is the content, right? So let me close it out. Now we want to concat this two file, like we want to see like, let me first show you what is present in this file2 as well. So file2, in the file2 we are having hello from file2. Okay, now if I concat these two files together, so file1 and file2. Okay, now we can see we are passing two arguments for this cat command, right? If I hit enter, now we can see I'm getting all the content from this two file. So we have understood like when you are passing different arguments, if this command accept multiple arguments, then you can like space separate those arguments and pass that to this command. Now along with these arguments, we can pass an option as well. So if I pass this dash n option, let's see what happens. So file1.txt and file2.txt. Okay, now you can see it is giving us the line number as well. On the first line it is having hello there, and right now we are only having a single line, so that's why it is giving you 1. Okay, so if you have anything in the second line, then the line number would get printed. So you can pass multiple arguments with the options as well. Alright, so in this video, we'll be discussing about text editors and word processors, right? So what are these things and what is the actual difference between these things? So text editors are kind of lightweight, okay? And you use text editor to edit plain text. It does not include any kind of styling information. and you use text editor for coding to write configuration files, or you are just taking some simple notes maybe. On those cases, you are using text editor. On the other hand, word processors are feature rich, right? So you use this word processor for text formatting, like let's say in a sentence you want to make a word bold, or you want to make a word italic. On those cases, you are using a word processor. So basically, if you are building any kind of like visually appealing documents like reports, charts, resumes, essays, on those situations, you are going with a word processor, right? So some of the example for text editor would be like if you are a coder and you are using any kind of editor like VS Code, Sublime Text, those will be text editor. Those does not include any kind of styling information with the file. So if you are creating a simple txt file, so on that file, you are just having those characters, ASCII characters, no styling information is there. There are some other examples as well, like Vim, Nano, Emacs. On the other hand, word processors are like MS Word, Microsoft Word is a word processor, Google Docs, Apple Pages, right? These are word processors. So this is the basic difference of text editor and word processor. And in this video, we will be discussing some of the text editor that is present inside Unix, and those text editor you will be able to access from your terminal. Now, inside Unix, you don't need any word processor, right? Because it does not have any graphical user interface, so you don't have to show anything visually appealing, right? But you need text editor to do the coding, to change the configuration, and do many more things, right? So these are some of the famous text editor that Unix have. So first one is this ED, right? And this is the oldest one. And Ken Thompson, that inventor of Unix, he actually written this ED. And when ED was there was no video terminal, right? So people were using the typewriter with the printer. Okay, printer was the monitor, you can say. Okay, then video terminal was invented, and next famous editor was VI. And Emacs and VI are kind of invented in similar times. Emacs and VI was like two most very popular editor out there. And then came this Vim. Maybe you have heard of this term Vim. Vim is short for VI improved, right? This part. So Vim was built on top of VI. Like they have introduced couple of features, new features, and created Vim. Now, these four editors were kind of like hard to grasp. For Emacs, you have to memorize a lot of macros and all. And for Vim, you need to like memorize a lot of key bindings, like how to navigate around the editors. Like it's kind of like there is a steep learning curve. Now, around early 2000, there's a like mailer program, I guess, that was called Pine. And Pine was basically built to send email, and email was sent by many like non-technical people as well. So Pine was pretty simple, like it has a text editor kind of fill, and you didn't have to like memorize all the hard things to use this Pine, right? So from this Pine, they have created a new code editor that was called Pico. So you already know, like this Pico is a measurement of unit, right? This is a smaller unit. It's called Pico, I guess. So from this Pico, they have created this editor Nano, right? So Nano is smaller than Pico, I guess. Now, if you do not have specialized skill to use these editors, Nano is for you. So in this tutorial as well, we will be opening Nano editor, and we'll be writing different dummy text, and we'll be saving those text with this Nano editor, right? And I will give you a sneak peek of this Vim editor as well, but we won't be touching this one. This is not used anymore. And yeah, VI and Vim is similar, and Emacs, like if you are interested on these things, then you can search for yourself. Alright, so in this video, we will be using our Nano text editor, and currently I'm situated in the desktop, and you already know this command, present working directory, right? Let me clear my screen, and let us just type Nano. Okay, hit enter. So this is the editor. Okay, and you can see that this Pico name is here as well. And right now, let's ignore this buffer thing, and this is all the shortcuts it's giving you, right? So if you want to get some help, you have to press Ctrl and G, right? So let's see, if I press Ctrl G, so you can see it is giving you some like documentation, you can say, right? And this is the special thing about this Nano text editor, right? So it will always give you some hint, right? So if you want to go to the next page, you have to press Ctrl V, right? uh, control Y will be the previous page, and we want to exit out, so control X. Perfect. Now this is the editor. You can start typing. So hello there, right? And to navigate around, you have to use your keyboard. I'm just pressing the left and right arrow key. And there's a second option, like if you have a mouse, and obviously you will be having a mouse, you can just option and click anywhere, and that will put your cursor there, right? So you can hit backspace to delete, hit enter to go to the next line, right? Rest of the things are like familiar to you. It's kind of similar to a traditional editor. To exit out, you have to again press Ctrl X, and rest of the things you can go through. So let me just hit Ctrl X. Let's see what happens. So now it is saying that save modified buffer. Buffer is basically a temporary thing, right? So when you are streaming any kind of video, nowadays you don't see any kind of buffer. So before previewing the video, before previewing a chunk, it will first download that video and it will put that thing in the buffer, right? Then once substantial amount is present in the buffer, then it will like show that to on your screen. Okay, so this is the similar thing. Buffer is like right now we're not saving this text in any file, right now this is in the buffer. So it is asking you like, do you want to save this buffer to somewhere? As expected, answering no will destroy changes, right? So if you hit Y or yes, then it will ask you for the file name that you want to save. And already I have shown you, like I have opened my terminal in this desktop window, right? So if you like enter the file name, that will save this on this desktop. And if you hit Ctrl C, that this will exit out from this process. You will be going back to the previous one, right? So let's hit Ctrl X again, and this time let me just press N, and we're not saving it. So that's kind of gone. All right, so this would be the first fill for our Nano text editor. All right, now instead of passing just this command, let us pass a file name as well, right? So this is a file path, and this is this file, file1.txt. By the way, you can see I'm getting some auto completion, right? So this is a different kind of auto completion. So I have actually installed a free tool. So this is called Amazon Q, right? So I'll be showing you like how to install this tool. So this is super helpful if you are working in a like terminal environment, and you will get some AI suggestions as well. So file1.txt, that's fine. Hit enter, and you can see this is the file. Let me just go to the end of the line, and let me just put maybe file1. Okay. Now to save these changes, what you have to do is, again, you have to exit, and to exit out, you have to press Ctrl X. Now in the top, you can see like it's not just showing you buffer, it's showing the file path that it is using, right? So if you hit Y now, it will replace this file with this new text. And if you like, as you understood already, like if you hit N, then your org will be gone, right? So let me just hit Y for this time. So again, you can see like it is asking you, do you want to overwrite this file or not? Like if you change the file name from here, then it will take the same content and like create a new file with that name. So this option is very helpful if you're duplicating something, right? So yeah, we want to overwrite this. So you can just hit tab to complete or hit enter. Okay. So that's kind of done. And if I do a cat file1.txt, you already know about cat. So you can see the content is file1. Right. By the way, I want to show you one more thing. Like if you want to go to the previous command, right, we will be introducing you this history thing. So there is a thing called history, like whatever command you have already like perform in your terminal, you can get that. So we'll be learning about this history in a like detailed manner. But for now, if you like in your keyboard, if you hit the up arrow, this will like circle through your previous commands, right? If I just press this keyboard up arrow single time, you can see this previous command that I have run, right? Now I'm pressing it again, and second previous command is there. All right. So again, let me go to the file, and let me just do a little bit of change and hit X. Yes, we want to modify. And now instead of file1, let me just put file1 copy. Okay. Hit enter. You can see it has created a new file. So if I do a cat now, so cat file1 copy.txt, you can see I'm getting this small letter file1, right? I'm really confused with one thing. I'm not sure, like, should I use this Amazon Q for this tutorial or not? Like, I will show you in the end, like, how to install Amazon Q and how to get the auto completion. And this is a fantastic tool, right? But most of the time, maybe you are not like using this terminal in your system, like whatever Mac or Linux you are having, or Windows system maybe. So if you are opening any remote server or any setup like that, and in that machine, let's say you don't have this Amazon Q installed, that will be a problem for you. So for this tutorial, let's not use that. So quit Amazon Q, and we don't need any kind of uh, suggestion, right? Whatever default suggestion Unix give us, that's kind of fine. So that suggestion is you have to hit tab, right? So file, and you already know, like if I hit tab, keep hitting tab, it will circle through all the options. All right, so in this video we will be start discussing about the Unix file system, right? And this will be the most important section, because inside Unix there's a philosophy that is followed called everything is a file, right? We'll be coming to this later. All right, so let us see the progression in computing history, like how file system was introduced, right? So pre-Unix era, like around early computing days, you can say, so there's a concept called flat file system. So nowadays you are familiar with directory, or if you're coming from an Windows environment, then folder, right? So there is no concept of folder in previous days. So you would keep everything, like let's say there's a single folder in your computer and you are keeping all of your file in that same place, right? So you can see, like that's a kind of like messy situation, right? It will create a mess very soon. All right, so there is no concept of directory or folder, so around that time. So after that, around 1965, there was an operating system called Multics, and Unix was highly influenced from this Multics, right? So Multics first introduced this hierarchical file system like this. So let's say you are having a root directory, and inside that you are having multiple directory, right? So inside root I'm having home, and inside the home I'm having pictures, videos, those things. And around 1971, Unix actually like adopted this system, right? So it also followed this hierarchical file system. Now there is a subtle difference between Unix file system and Microsoft file system, right? And maybe you are familiar with Microsoft's file system as well. Now both are kind of similar, like both follows this tree structure, right? But the only difference is Unix follow this single tree structure, right? There is a single root inside Unix. But what Microsoft does is it will assign some drive letters. Like let's say you are having a single hard disk, right? Like it will divide this hard disk into multiple partition, right? And it will assign some number to that, like C drive, D drive, right? And then you are having a tree. Okay. So this is the main difference between Unix file system and MS-DOS or Windows file system, you can say, right? And inside Unix, let's say if you are mounting any kind of USB, like you are inserting your pen drive maybe, or you are inserting an external hard disk, like that will also show you like as a directory under this root. But in the Windows system, that's not the case. Like if you add an external drive, like it will assign a separate letter for that. So let's say if you're adding an external hard disk, that might get this E drive, right? And all the content will be there after this. Okay. But inside Unix, under the root, you will be having that hard disk, whatever you are adding. So for now, this will be the main difference between Unix file system and MS-DOS file system. There is some like minor difference as well, but yeah, we'll be learning that in the later section in the course. Now let me show you a typical simplified view of the Unix file system hierarchy, right? So you already know at the top, we'll be having our root, and we denote this root with a forward slash. And then these are some generalized directory that you can have, right? Now I want to mention one thing. You already know, like Mac OS, Linux, these are coming from Unix, right? And Linux has many distribution as well, like Ubuntu, CentOS. I don't know why I have written entry here, Kali Linux, like that, right? So the main thing is, it might be the case that whatever directories you are having in a Ubuntu system, maybe the names are changed in macOS, or macOS has some extra directories, or CentOS has some less common directories. Okay, that might be the case, and that's not our focus. I just want you to have the feel like there will be a root directory, And like this bin is called binary, like operating system will be storing all the essential binaries here. Right now we don't know what the binary is. In the upcoming videos I'll be introducing you to these binaries, right? Then for boot loading purposes this directory is used. If you have any kind of drive, external drive devices, those data will be coming here. This is a very important one, that is home directory. Like there is a concept called user. The next section will be users and groups. So you can have multi user for your computer. You already know that, right? In a computer you can log in as different user, right? Those user specific data will be stored under this home directory. Now maybe in Mac OS home is called user. In Ubuntu maybe that has a different name, right? But the concept is similar, right? Similarly, shared libraries will be stored in this lib. Temporary files will be going to this tmp folder. This is user specific system requirement files. Like if the user is installing any kind of softwares, then those binaries will be going here. Shared library will be going here. If any kind of variable configuration you are having, those will be going here. Okay, these are like some of the basic introduction I can give you, for some of the common directories that Unix have. Now, as I have mentioned already, for different operating system, names, directory names might differ, and some operating system might like hide some very special or very sensitive directories from the user as well. So in the next video, let us actually open the terminal. And before going to that, let me tell you one more important thing. That is, I have already mentioned like this root will be mentioned and as a forward slash, right? And the user directory can be referred as this tilde character. That is in the standard keyboard that will be coming under the escape, I guess. Okay, so this is called a tilde sign. So yeah, we'll be understanding that, no problem. I just wanted to mention that. So in the next video, let us actually open our terminal window and let us try to navigate around it. I'll be introducing you with a couple of commands, new commands to navigate around the file system as well. All right, so before jumping into the terminal window, I just want to share a couple of more concepts with you. So there's a concept called path. Maybe you are already familiar with that, but there's a thing called absolute path and relative path. And with this Unix file system hierarchy, we'll be understanding that, right? So you already familiar with this. We are having a root directory, and inside that we are having a couple of more directories, right? And I have shown all the files in blue, and these are all the directories. So let's pick this videos directory. There's a thing called absolute path, and absolute path would be this one. So root, and inside the root there will be home. Inside home, this is John directory, and inside that this directory videos, right? So inside the Unix file system hierarchy, every unit, be it a file or a directory, will be having a distinct or unique absolute path. So in this videos directory case, we are having this root, and you can see like we are using this slash forward slash separator, right? In a Windows system, you use backslash, but we are not interested on that. So to separate these directories, we are using forward slash. So root, home, John, and videos. And when you are mentioning this absolute path, you don't have to mention this root one. Okay. So you will just start with the forward slash, right? So this is the absolute path. You start with the forward slash and then home, John, and videos. So these videos directories will be uniquely identified with this absolute path. Now, there is another concept called a relative path as well. So let us take the example of this photo 3. So this is a file, and the absolute path for this photo 3 would be this one. So slash, so this is the root. Inside the root we are having home. Inside home we are having John, photos, and finally photo 3. Okay. Now let's say you are inside this John directory. Okay. So if you are inside this John directory, so relative to this John directory, the relative path for this photo 3 would be photos and then photo 3. Okay. I have already mentioned whenever we are using the command line interface, we'll be opening that terminal in a particular window. So let's say right now my position is here. So I am inside this John directory and I have opened my terminal window here, right? Then the relative path for this photo 3 would be photos and then photo 3. Okay. So this is the difference between absolute path and relative path. Now let us discuss 3 very important commands to traverse around this tree. So the first one is this present working directory, or PWD for short. Now you already know, like you open your terminal window into a directory, right? Let's say I have opened my terminal window into this chown directory or my username directory. Okay. So if you publish this pwd command there, it will show you the path for this present working directory. Okay. And that will be the absolute path. So for this John, the absolute path would be /home/John. So this would be the absolute path if you like run this pwd command. Then the cd command is to change the directory. Change the directory means, let's say you are in the John directory and you want to go to this root directory maybe, right? So you will be publishing this command. So cd and then like the absolute path or the relative path of that particular location. So if you want to go to the root directory from this John, then you will be having this command cd and the root directory location. Okay. Now you can mention some relative directory as well. So let's say you are inside this John directory and you want to go to this videos directory. So if you are mentioning absolute path, then the command would be home/John/videos. Now, irrespective of your present working directory location, if you mention the whole absolute path, then it will take you to this videos directory, right? If you mention the whole path, whole absolute path. But if you want to mention only the relative path related to what? Relative to this John directory. So that would be only cd videos. Okay. But let's say if you are inside this lib directory, right? And you are publishing this command cd videos, and then this will give you an error because there is no videos directory inside this lib. All right. And last and the final command is this ls command. And ls command will basically list everything. So let's say you are inside this photos directory. If you publish this ls command, it will show you all the contents of this photos directory, right? Immediate content. So inside this John directory, if you publish the ls command, it will show you two directories only. All right. So I have opened my terminal in this desktop directory, right? And right now, this primary prompt is showing this desktop. And previously, it is showing my username, if you remember correctly. So from now on, whatever directory you are opening in your terminal, like in our primary prompt, you will see this directory name, right? And how to configure these things, we'll be learning that in the upcoming section. But yeah, I am in my desktop directory. And to confirm that, let us publish this command pwd, that is present working directory. And this will return the whole absolute path, right? So inside root, we are having users. Inside users, this is my user directory. And inside the user directory, I'm having this desktop. All right. Now from the UI, you can see I have a couple of files and directory present in this desktop directory, right? So if I do a ls now, ls is short for list, you can say. Okay, you can see like it is giving me all this directory. All right. Now let's say I want to go to this directory one. So I want to change the directory. So to do that, you have to do cd or change directory and the directory name. So directory one. Now you can cd into this directory one in two ways. The first one is you can mention the whole absolute path. That would be this one. So let me copy this and paste it here. And then directory one. So for directory one, this would be the absolute path, as directory one is inside desktop, right? So if I hit enter, you can see I am inside the directory one. Okay. So if I publish the pwd command now, present working directory, and this is the absolute path, and we have mentioned that here as well. Okay, now let me go back to desktop. So I have copied this. So cd and this. Okay. Again, my desktop directory. And now instead of using this absolute path, let us try to use this relative path. Okay. So I'll be just mentioning cd, and as directory one is present inside this desktop, I can just mention directory one. Okay. Or dir one. All right. And if I hit enter now, you can see it is taking me to this directory one. Okay. So this is how you navigate around different directories inside Unix. And if I do ls now, directory inside directory one, I don't have anything. So this is an empty directory. Okay. So let me do a clear now, and let's cd into the root of our system, right? Cd, and I'm just mentioning the root. Okay. If I do an ls now, you can see these are the things present inside this root. You are already familiar with these things like this opt, user, this opt, user, temp, sbin, and I can go to this users now. So cd, and I'm hitting tab for auto completion. Again, do ls, and I want to go to this showon directory, ls, and inside that I will find this desktop. So cd desktop. Let me do a clear now and ls, and again we can see all the files and folders. All right, so this is how you can navigate around. One very important thing you have to know that they have introduced some sort of symbols for different directories, right? So this for the root directory you already know, like you can denote your root directory with this forward slash. Let me just zoom in a bit so that you can see properly. Yeah, so for the root directory the symbol is forward slash, and your username directory will be this tilde. Okay, so that is under your escape character, I guess. Yeah, in your keyboard, quadri keyboard. So this is for your username directory, and current directory will be denoted as this dot, right? And parent directory will be denoted as double dot, and the previous directory will be denoted as this dash. So if I show you the previous structure again, so root will be denoted as forward slash. This John, like if you are logged in as John, then this will be equal to tilde. And let's say I'm inside this home directory, then home will be equal to dot. And as you are inside this home directory, this root will be denoted as double dot, as this is the parent directory. And let's say when you are inside home, you publish the cd command and you went to the sleep directory here under this usr. Okay, then while you are inside this lib directory, this dash, this dash will be assigned to this home directory because this was the previous directory. So let me show you these things in action. So you already know this cd command, so cd, and if I put forward slash, and this will take me to the root directory. So let me go back to desktop. So to go back to the previous directory, I'm just putting dash here. So again, I'm at the desktop directory. To go to the user directory, I'm just putting cd tilde, and I'm at my user directory. I can do ls here. You can see all the things that are present. And let's say inside user, you know, like there's a desktop directory, right? So I can do it like this, desktop. Okay, so I'm at my desktop directory now. Now this dash and double dash, if I do an ls and just pass this flag dash a, so this will show you everything, right? And let me show it in a list format as well. You already familiar with this. So if I publish this command ls dash al, so inside this all view you can see this dot and double dot, right? So this dot will be pointing to the current directory, and this double dot will be pointing to the parent directory, right? If I open an empty directory for you, so let me clear out, and right now inside directory 1 I don't have anything. So let me cd into that directory 1, and let me do a ls-la now. Okay, so you can see inside that empty directory as well, you are having this current directory and the parent directory. So while you are inside directory 1, if you publish this command cd double dot, okay, so this is pointing to the parent directory, and the parent directory of directory 1 is desktop. So it should take us to the desktop directory. So hit enter and we are in the desktop directory. And one more thing is, when you are mentioning the path, if this is not a file path, then you can end that path with a forward slash as well. So if I go to the parent directory, I can do it like this as well. Okay, and let me go to the previous directory again. Perfect. All right, and if I go to this directory 2 now, I can do it like this as well. So cd dot slash directory 2. So dot slash meaning cd, dot is representing the desktop directory, and inside the desktop I'm saying go to directory 1. Okay, and sorry, not on 2, and I'm inside directory 2. So you can memorize these things. This will be super helpful. All right, so in this video we'll be learning how you can create different files inside Unix, right? So you are already familiar with the Nano way, right? So you can just open the Nano text editor, and if you want, you can give it a file name now, or at the time of quitting you can give the file name. Okay, but let me just give the file name here. So test file maybe .txt. Now one more thing is, inside Unix it's not mandatory that you put this file extension with the file, right? This is just for you to understand. So hit enter, and we have opened our Nano text editor. Now we can just put some text here. Let's say hi there, and it is giving you some suggestions as well. Hit Ctrl X to quit out, and yeah, hit OI and enter. Now we can see it has created a test file. Okay, I can just do a cat and test file.txt, and this is the content. So this is option number 1, and there are many other options as well. So Nano is a text editor. If you open your file with Vim text editor, you already know like there are multiple text editor inside Unix. You can create a file in that way as well. Okay, now let me show you another way. That is, there's a command called touch, right? touch. Now touch command will take an argument, like the file name, you will be passing it as an argument, right? So let me pass it test file2 maybe .txt, and this time let's not pass any kind of extension, right? So touch test file2, and you can see it has created this test file 2, right? Now in my graphical user interface, it is not showing you this icon, right? This txt icon, this file icon, because Mac OS does not know like this is a text file or this is any other kind of random binary files, like what is the file type. So to tell the operating system that this is a text file, we put this kind of extensions, right? But inside Unix that does not like have any kind of meaning. So I can just open this test file 2 with my Nano text editor now. So test file 2, and let me put some text here. So hi there, perfect. Hit X, Y, enter. So now I have put some text inside this test file 2. Now if I do a cat and test file 2, you can see this is that hi there text. So these are the two ways you can create files inside Unix system. Alright, so in this video, we'll be discussing some of the commands that you use to view the content of a file, right? So you already familiar with cat, okay? So if I just do a cat file1, and there's a file called file1, right? File1.txt. So it is showing you the text of that file. Now cat is basically short for concat. So if you want to concat the content of multiple files and like say it together, then you will be using this cat command. Now if you're just passing on argument or on file as an argument, then it is just showing you that content. But this is the actual use of concat or cat command. So file1, and let me just mention file2 as well. So now we can see I'm getting the content from both the files. So this is on approach, and this is very popular, right? So like if you quickly want to see like what are the things present in a file, you can use cat. Now there's some problem with cat. Okay, so let me show you that problem. So let's say there's a big file .txt, right? So this is like there's a lot of text here. Okay, so let us try to cat this file. So big file.txt. Now you can see like it is giving you a lot of text, and you are scrolling with your mouse to see everything, right? And for some of the servers, when you are using this terminal, you don't want to use your mouse, right? So there are some other commands for that as well to like view the file. So there's a command called more. Okay, so more big file.txt. Now this will actually give you a paginated result of the whole file, right? You can hit your spacebar and it will like show you the next page, and this is the end. Okay, if you hit your spacebar again, you can see it is quitting out from that more command. So more is used to view a large file in a paginated format, right? But there's some problem with more as well. So more only supports like forward navigation. So you can go to the next page only. If you want to go to the previous page, there is no way of going to the previous page, right? There is a phrase called less is more, right? So this is nothing to do with computer science. So basically they have created a new program called less, and less has a lot of additional functionality over more, right? So again, this is kind of a joke in the programming industry. So less is more. And let me run this less command, and now big file.txt. So you get the similar interface of more, but now I can hit the spacebar, or in my keyboard I can press this F to go forward on page by page, right? But if I press B, then you can see I can go to back as well. So I'm pressing B, and this is my first page, and if I press F, I'm going to the next page. And also if you want to search anything, let's say I want to search the word standard here, so you can just enter /, and and this will search the odd standard. Let's say this standard odd is in the previous page, then you cannot use this forward slash, you have to use this question mark, right? So let's see this question mark the, so yeah, so this is on occurrence, and now you can just press N to repeat the search. Okay, so there are many occurrences of the, and to quit out from this view you just have to press Q. So you will be using cat to quickly see the content of a file, okay, but it will give you this kind of scroller behavior. And if you want a paginated view, then you'll be using less, not more, because less is more. All right, so less big file.txt and hit spacebar to go to the next page, hit B to go to the previous page, right? And once you are done, you can hit Q. All right, so in this video, we'll be discussing how you can create different directories inside Unix, right? So you already know how to create different files. Now we'll be learning how to create different directories. So there is a single command that is mkdir, or short for make directory, I guess. And you will pass the directory names as arguments, right? So let's say I want to create test directory 1 and also test directory 2. If you want, you can create on direct single directory as well. Okay, but I want to create 2 directories here. So if I hit enter, you can see it has created test directory 1 and test directory 2. Now, sometimes you will be creating different nested directories, right? So let's say you want to create a directory called NML, and inside that, you will be having a directory for cat. So to do that, if I do it like this, so let me clear out first. So mkdir and inside NML and cat. Okay. So it will give you some error, that is no such file or directory called NML. Okay, but if you have already a directory called NML, then it will go through. But if you want to like create this directory and all the necessary parent directory as well, then there is a flag for that as well. So that is mkdir.p. P is for parent. Okay, now if I do it like this, NML/cat, right? So if I hit enter, you can see it has created a new animal directory, and inside that I'm having a cat directory. All right, and I can ls from here as well. So ls, and this is that animal directory. Let me cd into that and do ls again. So this is that cat directory. So this is how you can create different directories or nested directories inside Unix. Alright, so in this video, we'll be discussing about moving and renaming files inside Unix, right? And you handle both of this operation with a single command, that is mv, or short for move. So to move any file, you just issue this mv command, and first you mention the target. Let's say I want to move this file 1 into this directory 1. Okay, so I'm at my desktop. So let me just ls. Okay, so you can see this is the file 1, and I want to transfer this file on inside this directory 1. So mv and the target, that is file1.txt, and I want to transfer this file to directory 1. So then the destination, okay, and destination is directory 1. All right, and if you do not mention any file name here, then like this file 1 will be the file name inside this directory 1, right? So let me show you what do I mean by that. So hit enter, so you can see file 1 is gone, and if I do ls for this directory 1 now, so inside the directory 1 I'm having file 1. By the way, with the ls command you can also pass an argument, right? It's not necessary that you first have to cd into directory 1 to like issue this ls command. You can just ls and then mention the path to see all the content inside that directory. All right, so you can see we have moved this file 1 into this directory 1. Now let me revert back. Okay, so to revert back again, I have to do mv and directory 1, and we are having one file, that is file1.txt. So this is the source, and we want to move it to this current directory, and current directory is this desktop. Okay, so now if I do ls dir1, so inside dir1 I don't have anything. So let me show you another interesting thing, that is when you are mentioning the destination, you can mention the file name as well. So what do I mean by that? That is file1.txt, and again inside directory 1. Now file 1, let's call it file1 new or copied.txt. Now this mv command will move this file inside this directory 1, and it will change the name as well. Okay, so if I hit enter and ls directory 1 again, you can see now the file name is file1copied.txt. So to rename any file, you'll be using this feature of mv command. Okay. So let's say we want to change the name of this file too. Okay. So what we can do is mv and first the target, that is file2.txt, and I want to change the name of this file, but I don't want to move the file. Okay. So I can do it like this. So file2, and let me call it renamed. Okay, .txt. If I hit enter, you can see that only the name is changed. Okay, so in this way you can rename any file with move command as well. So let me cd into directory 1. Let me do a ls, and this is the file uncopied. So I want to rename this. So to rename that, file uncopied to just file1.txt is fine. Okay, and if I do an ls now, so this is that file. All right. Now, let me go back to my desktop directory. Let me create another file named file1.txt. Okay. So I'm having file1.txt, and inside this directory 1 as well, I'm having file1.txt. And the content of this directory 1 file1.txt will be, so cat directory 1 file1.txt, that is file1. Okay, and in our new file that is present on the desktop, let me add some text here as well. So file1.txt. So this is new file on desktop. All right, so perfect. So if I do a cat file1.txt now, you can see new file on desktop. Now I want to show you one thing. So if I do mv and file1.txt, and I want to transfer this file inside this directory 1. Okay, but inside directory 1 there is another file1.txt. Okay, so if I hit enter, it will replace this directory 1 file. Okay, this file 1. So let me show you. So cat directory 1 and file1.txt, you can see this new file on desktop, and whatever file that was present previously in directory 1, that is gone, that is completely gone. So this mv command, it's kind of destructive, okay, by default. So that's kind of a problem. You can actually avoid this. So let me show you how. Okay, so let me clear out, and right now inside directory 1 we are having file1.txt. Okay, so let me create another file1.txt inside desktop with this dash command. So file1.txt. Perfect. Now we'll be passing a flag into this mv command, that is this I flag. I is short for interactivity. So let me mention the target, that is file1.txt, and the location will be directory 1. All right, now if I hit enter, it will first ask you that override directory 1 file1.txt, yes or no. If you hit no, then it will quit out from the operation. Okay, but if I hit yes, then it will overwrite. All right, so this is a very good habit to use this mv command with this I flag. Okay, in the upcoming videos I'll be showing you like how you can actually merge these two. Like when you will be issuing this mv command, it will automatically take this I thing as well. But right now, if you do not know that machine, if you are using mv command, then you should be using this I flag. Okay, and there are many other flag as well you can use, that is this v flag. So let's say mv and v for variables. So whatever this mv command is doing, it will keep telling you. Okay, so let us pass this v flag as well, and the target would be inside directory 1. We are having file1.txt, and we want to like bring back that file1.txt on desktop. So hit enter. Now you can see like it is giving you some preview that yeah, directory 1 file1.txt is coming into this file1.txt. Okay, so this is happening because you have passed this verbose flag. All right, so this is the mv command. You will be using this mv command to rename files as well, and to move different files and directories. Now we are good with how you are transferring different files into directories, right? Now let us see how we can move different directories as well, and for that we'll be using mv command. So let's say I want to move this directory 1 inside this directory 2. So same thing, mv target is directory 1, right? And we want to move this into this directory 2. So directory 2, all right? So you can see inside directory 2 now, we should have this directory 1, right? And if you remember correctly from the previous video, you know this animal has an like child directory inside it. Okay, so let us try to like transfer this animal directory into this directory 2 as well. So to do that, mv, again the target is animal directory now, and we'll be moving this to this directory 2. So directory 2, perfect, right? So it's possible to move different directories. If that has a like nested directory, that doesn't matter, you will be able to move that as well with this mv command. Okay, so yeah, this is for moving files and directories inside Unix, and also you will be using mv command to renaming files and directories. All right, so in this video we'll be learning how you can copy different files or directories inside Unix, right? So we'll be using this command cp, and cp is short for copy. So let us actually copy this file 1 into this directory 2. All right, and the signature of copy command is almost similar to mv. All right, so cp, first you have to mention the source, that is file 1, and then the destination is directory 2. All right, if I hit enter, then it has copied the file into directory 2. So let me ls for directory 2, and you can see this is that file1.txt. Now with this copy command also you can pass different flag, right? Like you are already familiar with this I flag, interactivity flag, right? So if you don't want to override anything, you can actually pass this I flag, and it will ask you like this file already exists there, do you want to overwrite or not? By the way, if you are not passing this I command, by default, similar to mv, it will overwrite anything. Let's say right now inside directory 1, we are having a file1.txt, and on the desktop as well, we are having a file1.txt, right? So if I copy this file1.txt into directory 1, then it will replace the existing file inside the directory 1. If you do not want that, then you have to pass that interactivity command. All right, so let me show you that. So again, I'm targeting file1.txt, and this time we will be copying this file into directory 1. Let me just pass the I flag as well. Perfect. If I hit enter, then it is asking you that this will be overwritten if you run this command. So hit N, and you can quit out from that process. Now there's a subtle difference between mv and cp command about how you are applying this command on a directory, right? So you already know, if you are using mv command with a directory, like it will behave in the similar way how it is behaving with a file. Now let us try to check that similar thing with cp command as well. So we'll be trying to copy this directory 2 inside directory 1. So let's see what happens. So cp directory 2, and we want to copy that into directory 1. Perfect. Hit enter, and now it is giving you an error that directory 2 is a directory. So by default, Unix will prevent you to copy anything, right? So maybe there's a like very big directory in your system, and you accidentally copy it to somewhere. Okay, that will be a like expensive operation. So for that reason, by default, it is blocked, and you can actually override that as well. So to override that, you have to pass a flag, that is R for recursive. All right. So now if I do directory 2 and I want to copy it to directory 1, okay, if I hit enter, you can see inside directory 1, I'm having directory 2. And if directory 2 has any kind of like nested directory, that will be copied as well. So inside this animal directory, we have a nested directory called cat, right? So let us try to copy this animal directory into directory 1. So cp animal and directory 1. So by default, it will prevent us. So let me press my up arrow, and this is the previous command. And now we'll be running this command with -r or recursive, right? If I hit enter and ls directory 1 now, you can see we're having animal. And let us go to directory 1. Let us go to animal as well and do ls here. You can see cat is there. All right, so let me go back to my desktop directory. So this is how you can copy different files and directory in Unix. All right, so in this video, we'll be learning how you can delete any file or folder or directory inside Unix. So there's a dedicated command for that, that is rm, short for remove. So let me create a new file called delete me.txt maybe. Okay. And if I do rm now delete me.txt and hit enter, it will delete that file. So this is as simple as that. But when you are deleting any kind of directory, it will ask you to pass some additional flag, like similar way you are passing flag in copy command, right? Because when you are deleting anything inside Unix, it's not like it will put this file into recycle bin or trash can, right? When you run this command and it is successfully deleted, then it's gone forever. You cannot recover that file. Okay, so use this rm command with caution. So let us try to delete on directory. So let us see what are the things present inside this directory 1. So there are many things, right? And inside directory 2, we only have this file under txt. So let us first make this directory to empty, right? Then we'll try to delete this directory 1, which has some content in it. And after that, we'll be trying to delete a directory, empty directory basically, right? So let me delete this file under txt. So to do that, remove directory 2 and file under txt. Now for a couple of commands you didn't notice or not, I don't know. Right now I have opened my terminal window in the desktop and I'm deleting things from directory 2, right? It's not necessary that you have to cd into directory 2. I can just mention the path I want to delete, right? So, and this is a relative path, by the way. So if I hit enter, it should delete that file. So if I rerun that command, you can see directory 2 is empty now. Okay, so let us try to remove this directory 2. So rm directory 2, and I'm hitting tab to autocomplete, and this is giving you those options, right? So rm directory 2, and you can see there's an error called directory 2 is a directory. Okay, so to remove this directory 2, you have to pass this recursive flag as well. Okay, directory 2, and now if I hit enter, you can see it's gone. Similar case for directory 1. So let us try to delete that as well. So rm directory 1, and it is giving you some error that directory 1 is a directory. So rm recursive directory 1. All right, let's see what happens. So it's gone. And this r flag you can pass in a small letter as well. So let's remove this one. So it's gone. Okay, again I want to mention this is this very destructive command, right? So when you are running this command, make sure you know what you are doing, right? You cannot recover any file once you delete it with this rm command. Similar to other commands as well, you can pass this interactive flag with rm command. So if I pass this I flag, okay, so this is a directory, so it's just giving you the error. So let me pass this I flag with this file under txt. Okay, let's see what happens. So it is asking you for confirmation that are you sure you want to remove this, right? So if you hit enter, then it will remove it, or you can just press N and it will not delete anything, right? So this is a very good idea to always run this rm command with this I flag, right? And there are some other destructive flag you can pass. That is, one is force remove, right? So sometimes what happens is, like, some of the files does not have any write permission, right? We'll be coming into the permission part in the later section of this course, but yeah, if that does not have any write permission, then it will give you some error message, right? And you can actually pass this f flag to suppress those error messages as well. So let's say if you are having a like large directory and you want to forcefully delete everything, so this is a flag for that. So rf, okay, so rm dash rf, and let's pass this text directory too. So if this is a very destructive command, by the way, very 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 destructive command. It will not ask you anything and everything is gone. All right, so if you are a JavaScript developer, you may be familiar with node module or any kind of like cache files or those things, right? So in a single command you can delete those things. All right, so this is rm command, and we'll be creating an alias for this rm-i, and I'll be explaining what do I mean by that in the later section. All right, so in this video we'll be understanding what is a symbolic link, or symlink for short, inside Unix, right? So that is symbolic link, or it is called symlink as well. So symlink. Let me increase the font size a bit, and to understand the concept we'll be using this diagram. Anyway, so let us say you have in your system directory, you have couple of softwares, and one of those softwares is a software called Apache 2, right? And it will have a logs directory. But in your system, what you want is inside this variable directory, you have a logs directory, and you want to have all the logs and everything here. So to solve this problem, you can actually create a link of this log directory here, right? So when you will be going into this logs directory, it will show you this Apache logs, and this is not a directory, this is not an actual directory, this is a link, and this will be pointing towards this logs directory, right? So if you are coming from a Windows background, this is kind of creating a shortcut, and you can create a symbolic link for a file or a directory, and this will basically copy the path. And let's say you delete this logs directory, then also it will be there, just this link will be broken. All right, so this is symbolic link, and for some of the things inside Unix, you will be using this kind of symbolic links. All right, let us see this symbolic link in action. Okay, so let's say inside this directory one, I have a configuration file. So let me just ls, and you can see there's a config file. All right, and I want to create a symbolic link on my desktop for this configuration file. So to create the symbolic link, you have to use this command ln, or short for link, right? And you have to pass a flag called s, and s is short for soft link. And there's a concept called hard link, and 99% of the time you will be only using, if you are using any kind of symlink, then you will be using that soft link, right? That's why I'm just showing you the soft link. Okay, so we are passing this s flag. Then you have to first mention the source, and the source would be inside directory 1, and we are having a configuration file. And inside the desktop, we want to call it, this will be the symbolic link name. All right, so let us call it, if you want, you can call it config, but to identify it properly, let's call it config from directory 1 maybe. Okay, this is not necessary, like you can, let's call it config. Hit enter, and you can see it has created a symbolic link, and my operating system is giving a shortcut sign as well. And if I do a ls/la now, or just list view, that's fine. So you can see this is the symbolic link, and it is kind of pointing, like in the Unix system as well, it is showing you with this arrow that this is pointing to some other path. Now if I get this config file, you see right now it's empty, right? So let us put some text here. So let us open this file. So I'm opening the original file that is inside the directory, and config, and this is some configuration. So I've said that. Now if I do cat config, you can see I'm getting that text. And if I do it like this, so directory 1 and then config, I'm getting the same thing. Now I can rename this symlink if I want as well. So you know, to rename the file, you have to use this mv command. The thing I want to establish is, like, you can treat this symlink as a file. All right, so let me rename this. So let's call it symlink config. Okay, and as you know, first we have to mention the source, then the target. Okay, if I hit enter, so it has changed the name. Now if I do smconfig, we're getting the same thing. Okay, let me clear out. All right, so this is symlink, and now if I delete the actual source file, let me delete that. So rm, and the file is present inside the directory 1. So config, you can see the symlink is still there. Now if I want to cat this, let's see, so it does not find anything on that location, right? So just keep one thing in mind, symlink is nothing but you are copying the path and you are putting it here, right? You are copying the path, nothing else. You are not copying the file. All right, so that's it for symlink. All right, so in this video we'll be discussing a concept called wildcard inside Unix, right? And why you need this kind of wildcard, we'll be learning this in a moment. So let me just give you a brief about these things. Okay, so this is asterisk, and this will actually match 0 or more characters. That means, like, if I am, let's say this text, right? This star.txt. That means if you're considering this, let's say I'm writing star.txt. So this will match file.txt, cat.txt, but it will not match doc.pdf. Right, because like this star is representing 0 or more character, yeah, file, cat, these are matching, and then there will be a dot and txt. So these two files are matching, but this is not matching because at the end it is coming PDF, right? And exactly one is represented with this question mark. So let's say I'm having this text file question mark dot txt. Okay, so this will be matching file1 dot txt, file2 dot txt, but it will not match file10 dot pdf or 10 dot txt. Okay, cause this is exactly one. So file after file there must be one character and then the dot txt, right? But here this is not the case. After file we are having two characters and then txt, so this will not match. And then this bracket wildcard, so whatever you put inside this bracket it will match with that. So file1.txt, file2.txt will match, but file3 won't. And inside bracket you can actually mention different range as well. So I can mention 1 to 3. In that situation file3 will be matching as well. And there's a other wildcard, I didn't mention it here, so let me show you anyway. So there is this curly braces, right? With the curly braces is almost similar to this square bracket. The only difference is you just mention this comma separated values. So if I just mention file 1 comma 3, that will only match this one and this one, not the file 2. But yeah, these three, you will be using these three the most. All right, so let me open our terminal and let me try to show you like how these things are working. All right, so if I do a ls.l now, you can see I'm getting all the files, right? So let me clear out. Let's say I just want to see what are the files that are present with the .txt extension, right? So I can just do it like this. So .txt. So it will only show me all the files that has an ending .txt, right? Now let's say I want to only on a C that has this at the start that has this file, and then it can have anything, and then at the last it should have .txt. All right, in that situation I'm getting this file 1, file 2, but this big file is not matching because at the start it is having big. So this is how you are using this star wildcard entry. All right, now let's say we want to match this one. So file, and after this dash there will be a single character and then .txt. In this case only this file 2 and file 1 should be matched, right? So you can see, sorry, I should mention ls as well, .txt. So in this situation you can see it is only matching with file1.txt and file2.txt. All right, so with this ls command you can easily search inside a directory that what are the things are present. And in the next lecture we'll be learning about a new command called find, and with that find command also, using this kind of wildcard, you will be able to match different files and directories. And lastly, let me show you this one as well. So ls, let's say I want to match only file 3, okay, .txt. So no, nothing is there. So if I just have one, yeah, one is matching, on 2. By the way, when you are using this square bracket, you are not mentioning any kind of comma, right? So whatever that is present here, everything will be matched. So what do I mean by that? So let's say if I'm having a here, then file dash a would be matching as well. But right now we don't have any file called with that name. That's why it's not giving you anything. Right, and it supports range as well. So let's say 1 to 2. If I mention it like this, so it is matching as well. And you can use this glob pattern or this wildcard with any kind of commands. So let's say I want to remove all the directories that has this kind of naming structure. Okay, so let me try to remove that. So rm, and as we are removing a directory, you know, we have to mention this r flag. Then I can just do it like this. Okay, if I hit enter, you can see those two directories are gone. All right, so in this video we'll be starting with users and groups inside Unix, right? And we'll be understanding why users and groups are important inside Unix, right? As you already know, in previous days these computer hardware are expensive, right? So let's say if I consider a university, maybe inside the university there is a single computer, and we are already learning about terminal. So with this single computer, multiple terminal are connected. So let's say this is the terminal for physics department, this is the terminal for maths department, this is the terminal for administration maybe, right? So let us take this example of this physics department. So inside the physics department there can be multiple users who are using this computer, right? So these can be a group of teachers who are using this computer, and they can have different access of different files. And for the student also, you can have a different group, and you can have all the students in there, and they can have their respective directories for their personal files, and they can access those files as well. So you can see, when you are having a single resource, single hardware resource, you have to logically separate different things. So that's why users and groups were introduced inside Unix, and Unix is a multi-user setup. So from now on, we will be having a complete section where I will be introducing you with different commands to create different users and see what are the users available in your system, to change their permission, and already like inside Unix everything is a file and directory, right? So we'll be learning how you can give different permission to different users as well, or assign different permission to group level. And let's say you are assigning a permission to this group level, and whatever users that are present inside this group, those users will be having those permissions as well, right? So let us understand those things one by one. All right, so in this video, we will start about some of the commands that you will be using to manage different users and groups. So the first command is whoami, and maybe already you have familiar with this command. And if you publish this command, it will just give you the current username that you have logged in with, right? And you already know that whenever you are opening any kind of terminal window, you have to log in with some user ID. So you can see, if I publish this whoami command, it's just giving me the username. And one more interesting thing is, let me quit out from this terminal. So I'm clicking here and quit terminal, right? And I want to open this terminal app again, right? So if I open this terminal app, by default, it is taking me to that user directory, right? And you already know, like, all the users will have a like personal directory inside Unix. So whenever you are logging into the Unix terminal, it is taking you to your user directory, right? And obviously this is configurable. So by default, if you want to change this login directory, you can do that. At the later section of the course, I'll be showing you that as well. So this is that command, whoami, to check the username. Now, whenever you are having any kind of user, that user will be a part of any group or multiple groups, right? So there's a versatile command that is id, right? So if you publish this id command, it will give you a lot of information. So let me just type id and hit enter. So these are all the things it is giving you, right? So the first thing is uid, or user id for short. And whenever you are creating any user, or whatever user you are having in your system, those users will be having some kind of like unique identifier, unique, like this kind of integer values, right? So for this particular user, this is the user id, and then the group id, and this is called a primary group. So primarily this user belongs to this staff group, right? And the id of this staff group is 20, right? So this is the group id, not user id. And as I have already mentioned, the user can be a part of multiple groups, right? So this is the groups. So, and you can see this is a comma separated list. So this user is a part of staff group, everyone group, local accounts, and there are some other groups that is made by the operating system as well. So if you just want to see like the user ID, then you can pass this flag u with the ID, and it will just give you this 501. Similar thing, if you just pass this G flag, then it will give you the group ID. And if you pass this capital G flag, it will give you the list of all the groups that the user belongs to. And instead of the ID, if you want to know the name, then you have to pass it like this. So with the U, you have to pass the N flag as well. Okay. And it will just give you the name of that user, or username, right? Or you can pass it like this as well. Right, similar thing for group as well. So G1, it will give you the group name. Let me clear out, and this will give you the list of all the groups that user belong to. So this id command is super helpful. You will be getting a lot of information about that particular user with this id command. And this id command is taking some flag, as you can see, but with this flag you can pass some parameter as well. Okay, so if I pass an username, that will give the details about that particular user. And if you do not pass anything, then by default it will just show the information about that current user, the logged in user in this terminal, right? But you can, if you want, like let's say you are an admin and you want to check the information of a particular user, maybe username is Bob. So you can pass the username and it will give you the details about that particular user. One more thing I want to mention here, unless you are a system admin for a Linux system or the Windows system, rarely you will be using any kind of command to create any user or delete any user or modify the group, right? So most of the time what we'll be doing is there will be a file and we will be just dealing with the permission and the ownership of this file, right? So for that reason, in this course I'm not showing you like how to create user, how to modify the group, so those kind of things, and that's kind of like beyond the scope of this course as well. So for that reason we are not dealing with the creation of groups and users, and that will be kind of redundant because there is a lot of things that need to be covered in this course, right? So we'll be just dealing with file ownership and file permission, or obviously the directory ownership and directory permission as well. If you are super interested about these things, like there are simple commands, like if you want to add a user, there is a simple command like user add, okay, or add user, okay, and user del will delete the user, or group add will be adding a group. So this kind of command you can search in the web and you can learn about those. But in this course we are not diving deep into these users and group things. All right, so in this video we'll be learning a familiar output of a command, right, I should say. So let me go to the desktop directory, and you already know these are the files and directory currently we are having, and we also have a symlink, okay, soft symbolic link, right? So let me just issue this command ls-l, and you already familiar with this l command, right? L flag. So this is the things we are getting, right? There are so many information. So in this video we will be learning one by one, like what are these things, okay? So let me quickly open my diagram. Okay, so this is the first thing, the first letter of this. So this is a 10 character thing, right? So rest of the 9 character will be coming to this part later. So this is the permission 9 character, and every letter, every character has a different meaning, right? So for now, just ignore this 9 character and just focus on the first one, okay? So this first one is mentioning the file type, okay? D means it's a directory. Okay, so you already know this animal is a directory, and if that is a dash, that's a simple file. Okay, these all the other files are simple files. Right now we're not showing any B character, so B character is block devices. Let's say you are inserting a hard drive, okay, that will be showing as a B. All right now I cannot show that to you because I don't have any hard drive mounted. And L is for link, symbolic link, and there's some other notation as well, but these are the common one. These two is like most common, this D and dash. So D for directory and dash is for regular files. All right, and rest of the 9 characters will be coming to that later. And next come this number. This is not that important as well. So this is called the hard links. You already know about the soft link. So hard link is a thing, and this will just show you like how many hard links this file or directory has. Okay, you can see this directory has 4 hard links. Okay, and the files generally, as a regular file, will have a single hard link. All right, so this is the count of hard link. Then this is this thing. Let me collapse out this as well so that you can focus on this part. So this will show you the user that owns this particular file or directory. Okay, so this animal directory is owned by this shown user. All right, and next same thing, the group that owns this directory or file, that will be showing here. So primarily this directory is owned by this staff group, right? And next, like if I run this command with human readable form, so ls-lh, h for human readable, you already know that. You can see this is the byte size, like the directory size is 128 bytes, and the file size is 2.3 kilobyte, right? The next part, this is the modification date of this particular file or directory. So first it will show you the month, the date, and the time, right? And finally the name. So this is kind of like self-explanatory. So this is the name, and if that is a symbolic link, then you are getting some additional information as well. So now you know, if you publish this ls/l command, then what are the things you are having in your screen. In the next video, I will show you like what is a permission for a particular file or directory, and what are these 9 characters are representing. All right, so in this video, we'll be discussing about two concepts, that is file ownership and file permission, right? So what are these two things inside Unix and what is the difference? Okay, so let us discuss about this ownership thing. Right, so let's say you have created a file.txt, and when you are creating the file, you have logged in. So if for my system, if I show you my whoami, so this is my username and I have logged in with this username, right? So whenever you are creating or I'm creating the file, by default, the file owner will be this user. So this is called the owner of that file. Okay, and you already know, like by default, every user will like belong to a primary group, at least one group, and that is called our primary group, and you already know that, right? So if I publish this id dash gn command, and this is my primary group. So whenever you are creating any file, like whatever the primary group of that particular owner has, so that will be the files group as well. So whenever you are publishing this command ls-l, so this first one is the owner by default, and owner's primary group will be the group for that file as well by default. Okay, so afterwards, if you want, you can change the ownership and group ownership as well. Okay, obviously that is possible. So this is the ownership part, and whatever other users are present in that particular system, those will be called others for that particular file. Okay, so this is a file, you have created a file, and whatever username you used to log in at that time in your terminal, that will be the owner for that file, and owner's primary group will be the files group. Okay, and during the ls-la command, it is showing you those two things. So this is the owner and owner's group, or like the files group, you can say. Okay, and afterwards, obviously, you can change these two things as well, and we'll be learning that part. So this is called ownership. So file ownership. I hope this is kind of clear. Now comes the permission part. So permission is basically, you can have 3 permission. Okay, read permission, like who can read the file. Write permission, who can modify or update the content of a file. And delete is also coming under write, right? If you have the write permission, then you will be able to delete the file. And execute is, right now we are not familiar with that part, but inside Unix, you know everything is a file. So programs are file as well. Okay, so to give you an example, this ls, so this is a program. Someone has written some code to list all the files that are present in the hard disk. Okay, so this is a program. So to execute, like to run that program, you need a specific kind of permission. Okay, so that's that execute permission, right? And we'll be learning about this execute thing as well. Okay, so permission can be 3 types: read permission to read the file, write permission to modify, update, or delete the file, and finally to execute, to run that file, you need execute permission. Okay, so now these 9 characters are actually representing those permission for each individual entity in your system, right? So the first 3 is for the owner, like whoever is the owner of that particular file, and next 3 characters are the permission for the group. Okay, so let's say inside this staff group, I have multiple users. So for those multiple users, I can mention the permission in these 3 characters. And rest of the other user, let's say I have 5 other users, and those users do not belong to this staff group, right? So to mention the permission for those others user, we will be using these 3 characters. So let's discuss about the owner permission. So R means read permission. So for this particular file, owner has read permission, owner has a write permission as well, but owner does not have execute permission. Okay, but for this symlink, so for this file, owner has the execute permission, and execute is mentioned with X. All right, so if the entity has the permission, then you will be representing with a letter, corresponding letter. So R for read, W for write, and X for execute. But if that entity does not have that permission, then you will be just mentioning dash here. Okay, so let's analyze this file to renamed. So the owner has the read permission, write permission, but does not have the execute permission. And whatever users that are present inside this staff group, those user can read the file but cannot change or modify anything or delete the file, or he cannot execute the file as well. Okay, and for rest of the users, other users, they can read the file, like they have the similar permission, you can see. Okay, they can read the file but they cannot modify or write or execute the file. In the upcoming videos, I will be showing you how to change the ownership and how to change the permission for different files. All right, so before going into the next section, we have to learn a very important concept inside Unix that is called root user. First, we'll be understanding why you need a root user and what is the main problem it is solving, right? So let's take an example. Let's say you have logged in as this user John, okay, in the Unix system. So when you are logging in with this John user, you will have the access and permission for all the directories and files that are present inside this John directory, right? You already know that. Like from this John directory, if you want to access something that is present inside this Bob directory, you cannot do that. And there is another problem. That is, if you're logging in as John, you cannot change or modify anything from these directories as well. Okay, and these are like system directories, right? To run the system properly, you need a lot of files and directories, right? These are all those directories. So let's say you want to perform some administrative task. You want to install a global software in the Unix system. So how to do that? Because if you're logging in as a normal user, you cannot like change anything, let's say inside this binary directory. So to add a new software, you have to add a new file inside this binary directory, and you don't have the permission as a normal user. So to solve this problem inside Unix, there is a concept called root user. So in previous days, there was a single user, root user, and root user will have a password. Okay, that is called the root password. And if you are logging in with this root username and root password, then you will have the access of everything that is present inside that system, like the whole file system access. It does not matter the file is present inside a private directory or not. Like if the file is present in the file system, you have the access. You can delete, read, execute, do whatever you want. So this is sometimes called administrative access as well. So to maintain the system, to do some housekeeping things, you need this kind of access time to time. Okay, so this is the concept of root user. Now there's another problem with this root user. Let's say you have a like fairly complex or large system, large Unix system, and you need multiple administrator to like do the administrative task. So the first solution can be you can share this root password with different people, different user, and they can log in as root user, and they can do the administrative task. Now you already know that's not a very good solution to share the root password with someone, right? So to solve that problem, they have introduced a concept called Sudo. Like Sudo is super user and do, right? Sudo is short for super user and do. So the concept of Sudo is you will be logging in as a normal user. Let's say you are logging in as John, and John will have a different password, right? He is logging in as John. Now he can publish this sudo command, and with this sudo command, he will be having a temporary root access. I will show you in action, like what do I mean by that temporary root access. So let's say John is logging in, and John is an administrator, and he has to change a file inside this tab directory maybe. So temporarily with this sudo command, he can get the root access and perform the administrative task, right? So this is the main reason why sudo was invented, or super user and do. And there's a file called Sudoers file. Okay, Sudoers. So this is the spelling. So I'll be showing you this file as well. And inside this Sudoers file, the first thing you can mention is, let's say you might have 100 user in your system, and you can create a special group called administrator, and you can write a rule inside this Sudoers file that only user those belongs to this administrator group can run this sudo command. No other user can assume the root access, right? So those kind of configuration you can put inside this sudoers file, and I'll be showing you that thing as well. And also inside the sudoers file, you can mention different access control as well. Like if someone is using this sudo command, how much access will that person be having? those kind of things you will be able to configure through this Sudoers file, right? So we have opened our terminal window, and now we'll be understanding the sudo command from this terminal. So I'm at my user directory, and let us go to a directory called etc, and that is present at the root, and then etc, right? So I'm talking about this directory. Let's say we're going into this etc directory. All right. So I'm at the etc directory. Let me clear out, and let me just run this ls-l command, and this time we'll be passing a new flag called d, right? And with this d flag, it will just show you the information for a single file, right? So let's say if I take this example of file2 and you want to know the details about file2, then you can just type ls-ld and then file2.txt or whatever the path is, right? That will just give you this. Because if I just do ls-l here, you can see there are many things that is coming, like there are many things that are present inside this etc directory, right? So for that reason, I'm just passing ls-ld. And if you do not pass any kind of argument after that, then it will just give you the details of the current directory, and you know the current directory is represented by this dot, right? So that's the thing. And let me clear out. Let me run the command again, ls-ld. Okay. So for this etc directory, this is the owner, and you can see the owner is root, and I'm logged in as Shobhan, because if I run this whoami command, you can see it is giving me Shobhan. So I'm not the owner of this directory, and the group ownership is Will, right? And this is the permission thing. So D is telling you that this is a directory, and this is the permission string. So for this root user, he can perform everything on this directory, right? Read, write, and execute. If any user is coming from this Will group, then he will be able to perform read and execute, but he cannot modify or delete anything from this directory, right? And for others user as well, other, like in this context, Shobhan is other user because he does not own this directory, right? So he can only read, not write or modify anything, and also he can execute. So we understood the permission. Now let us try to actually create a file, okay, in this directory. So you already know, to create a file, you just have to type Dutch and the file name. So let me just put hello.txt maybe. Okay, if I hit enter, it is saying permission denied. I cannot add anything in this directory because I don't have the proper permission to do that. I can only see the things that are present with this ls command. Now you have two options. You can sign in as a root user, and inside Mac I don't know how to do that. And the preferred option is you have to use that sudo command. Okay, now how to use that sudo command? You just type sudo followed by any command that you want to run, right? So previously we were running this command, touch hello.txt. So we are just prepending this sudo command with whatever command we want, right? If I hit enter now, it is asking you the password for this particular user that you are currently logging in, right? So when you will be entering the password from the Sudoers file, it will check like this user has the proper permission to be a sudo. So let me just enter my password and hit enter. And if I do a ls-l now, it should create a hello.txt. So there are so many things here. Yeah, this was that file. Okay. And for this, let me clear out and then we will talk. And for this hello.txt, you can see the owner is root and the ownership group is Will, right? So with the sudo command, we can easily create this file. Let me show you another interesting thing. So if I run whoami now, it is showing me Shobhan, right? So whoami is a command as well. So we can run this command with sudo as well. So if I run this whoami command with sudo, let's see what happens. Whoami. So it is saying, then if you are running this command with sudo, then you are a root. So this is how you can gain elevated access inside Unix. All right. So in this video, we'll be trying to change the ownership of different files and directories, right? So there's a simple command that is called ch or change and ownership. You can call it chown or chown, whatever you want, right? So this is that command. And after that, you have to mention the new owner name. So let's say I have a user called maybe Bob in my system and the new group. So maybe group 1. Okay, I don't know the group, but yeah, or maybe developer, right? And then the file path that you want to like change the ownership for. Okay, so let me clear out everything, and let us do a ls-l, and these are all the files currently we're having. So for this file 2.txt, let us try to change the ownership, right? So ch own, and we want to give this file ownership to root. Okay, and instead of staff, let's change it to everyone. All right, and there's a group called everyone in my system, and then the file 2.txt. Perfect. If I hit enter, so you can see we're having this operation not permitted kind of error, right? And now you know how to override this kind of error, right? So we'll be running this same command with sudo now. So let me copy this and let me paste it here. So if I hit enter, it is asking me for my password, and yeah, we have to copy it like with the command as well. Sorry for that. Right, and this time if I press enter, it will not ask my password, because when you are using sudo will remember your password for I guess 5 to 10 minutes, and that's configurable as well. So hit enter, and now the permission has changed. Let me clear out and ls-l again. So now you can see this is root everyone, and this is file2.txt. All right, so this is how you can change the ownership of any file or directory with this ch own command. And if you just want to change the user, not the group, then you have to mention like this, and after the colon you are not passing anything, or whatever existing group you're having, you can just pass that, right? And then the path. Or if you just want to change the group but not the user, then you will be passing like this. Okay, you got that idea. All right, so this is how we'll be using chown command or chown command to change the ownership of different files and directories. And for directories also, it's exactly same. All right, so in this video, we'll be discussing about how you can change different file permission, or it is called mode as well. Okay, change mode. So there's a command called change and mode, or mod, a mod, change mode. Okay, chmod. So we'll be using this command to change the file permission. So let me just do a ls-l to see all the files that are present. So let us take the example of this file, or let me just create a new one. So to create a new file, touch, and let's call it file on, because we don't have any file on, I guess. Yeah, file on.txt. Clear and ls-l. So now we're having file on.txt, and we'll be doing all the experimentation on this file, right? In the previous video, we saw like with that ch own command, how you can change the owner, like user owner and the group owner of this file, right? Now we'll be changing this part. And you already know like the first 3 character is the permission for this user. Okay, then next 3 will be representing the permission for the group, and rest of the users will have this permission, right? R is representing read, W is for write, and X is for execution. So if this file is a program or a script, you can run that file. Okay, that is for execution. Right now for file.txt, we can see the user can read the file, write the file, means modify the file, and he cannot execute that. So execution means I can run this file like this. So file on.txt. All right, if I hit enter, you can see permission denied. So this is how you can execute any file, or you don't have to mention this as well. You can just do it like this, txt. And we'll be understanding in detail, and we'll be learning about different programs, and we'll be seeing their content as well. Okay, right now, just forget about that. So to execute any file, you just have to do it like this. And as the user does not have the execution permission, it is giving us permission denied. So let's say this is a program, maybe file on.txt, and let me actually remove the .txt extension, because for a program we don't need any kind of extension, because with this .txt we are mentioning, like, Unix does not care, but yeah, for human it signals that this is a text file. Okay, and to rename a file, if you remember correctly, we just have to type the source. So this is the current file and the target. Okay, target is file. it should be file1. So we have written the file as well. Let me do a clear as well. ls-l. So now we're having file1 and we're treating this file1 as a program, right? So if I want to run this program, it is saying permission denied. Now let us actually add the proper permission so that this user can run this file, right? So to add the permission, what you have to do is type this command chmod or change mode, all right? And for user, the short form is U, for group it is G, and for others it is O, the initial, right? And whatever you want to change, on the left side you will be mentioning that, and there's an equal sign, and at the right you have to mention what you want the permission to be, right? So for our case, we want the user should have read permission, the user should have write permission, as well as the execution permission, right? And finally the file path. So for file 1, and we remove the .txt. So if I hit enter and do a ls-l now, you can see we have added that execution permission here, right? Now if I try to run this file and I'm hitting my up arrow, so it ran the file, but like no code is there for execution, right? And what do I mean by code as well? I'll be showing that to you in a moment. All right, so this is one way of changing any kind of permission, right? So again, if I show you the command, so you will be first mentioning what is the entity type, like other, user, or group, and then you will be just mentioning the permission, right? So let's say we want to remove this write permission, so you can just mention rx. So this should remove the write permission from that user. Okay, so you can see write permission is gone. All right, so this is one way. The second way is you write chmod and you do it like this. Say whatever permission it has, I don't know, and I just want to add this write permission. So you just have to mention plus and then w, right? So then the file path, file1, and let me just do the ld, and with this d flag, I'll be just targeting the file1. All right, so you can see now we have added back that write permission, and it's pretty simple, right? If I want to remove this read permission from the group maybe, or this is for others, so I don't want to give the read permission to others, so you have to do chmod, the entity is O, and there's negative and R. We want to remove the read permission. Okay, mention the target, and you can see that is gone, right? If I want to give maybe the execution permission to others, then we have to do it like this. All right, and in a single line you can mention multiple things as well. So this is one part. You can do it like this as well. Let's say for the user, we want to have only read permission, and for group and other, we want only write permission. Or for user, we want read and write, and for the group, we want only read permission maybe. And then the file path, if you hit enter, you can see it is just giving all the proper permissions, right? So this is how you can change the permission of different file. There is another way that is called octal notation, and let me just show you. So yeah, you can just memorize a couple of things and that might help you. So this is the permission column, and these things you can think like of a binary number, right? If nothing is there, then 0, 0, 0. If the rightmost value is present for x, then 0, 0, 1. Okay, and for this binary number, the octal equivalent is this, right? This 3 is 0, this 0, 0, 1 is 1, 0, 1, 0 is 2. You already know this. So if you just mention chmod 7 0, 0, then it will first give the permission for user, and 7 is rwx, so full permission, and 0 means no permission, right? So let me give you some example that will make this thing clear. Okay, so chmod, and we are mentioning 700 and file on. All right, so if I do ls-ld, you can see we are having full permission for the user. So first letter is for user, second letter is for group, and third letter is for other, right? So for the user, we are giving full permission, and for rest of the entity, we are not giving any permission, right? Let me change it to maybe for the user we want 7, and we want, let's say, 777. Okay, so I don't want you to memorize all these combinations, right? But sometimes, let's say 777 or 000 or 400, these will be like, these numbers will be useful time to time. So let's say chmod 777 and the file path. All right, so this will give the full permission to everyone, right? And let's say you want to remove all the permission, so 000 file 1. Okay, or you just want to like give the read permission only the user, so another common thing is 400. Okay, so this will just give the read permission to the user. So you can see now only the user can read the file. So I have just shown you these things because this is a shortcut. Okay, so to give all the permission to everyone, you like, if you want to follow this step, then a lot of things you have to write, right? But if you're just going with this octal notation with this 3 number, you can perform the job. So for that reason, for quick access, you will be using this octal notation time to time. All right, so in this section, we will be learning a lot about commands. So what are commands? You already know about a lot of commands now. So ls is a command. So we'll be learning what is ls, what is echo, what is this mkdir maybe. When you are writing these characters, how your terminal or the shell knows like where to go and how to execute these files, right? We will be learning the entire process of this command. And in the upcoming videos, we'll be learning how you can create your own commands as well. So let's say this is our terminal window and you are running this ls command. So when you are running this ls command, first, this is the terminal window and you know the terminal is used to communicate with the shell, right? So this ls command is going to the shell. Now, shell has a list of special directories, and on those special directories in your file system, it has some special files, special kind of files. So shell is going to the file system and it has a directory list to find out this ls file. So ls is a simple file and I'll be showing that to you as well. So from that file system, it will find out that ls file, and inside this ls file, there will be some machine code or binary code, you can say, right? And it will execute that. Execute that means from that operating system, it will make some system calls, and those are super low level. So basically the shell will run that file, right? And after running that file, whatever instruction that are given in that particular file in the binary format, that will be executed, and whatever output you are getting, shell will be getting that output and it will relay back that output to your terminal window. So this is what is happening. So again, if I recap, you are running this ls command. First, the terminal is sending this ls command to the shell, and inside the shell, there's a special kind of directory list. And from the directory list, one by one, it will check, like, let's say directory 1, directory 2, directory 3. So first it will check in directory 1 that if this ls file is present or not. If it does not find there, it will go to the next directory and then next directory. Okay, like that. So let's say in the second directory, it found that ls command. So it will pick that up. And then if that ls file is containing some bytecode, it will run that. And whatever output we are getting, it will relay back that output to the terminal window. So this is the whole flow, what is happening when you are running any sort of command with any argument or any flag. Now, as I have already mentioned, whenever you are writing anything in your terminal window and hitting enter, it will first go to the shell, and shell will look for a special location in your file system, right, to find out that program files. So now we'll be discussing about that. So there is a concept called environment variables inside shell, right? Environment variables are nothing but key value pairs. Like if you have any experience with any kind of programming language, you know the concept of variables, right? So you denote the variable with a name, and inside that variable, you store some sort of values, maybe number, string, or Boolean values. So similarly, in the shell, there are some environment variables, and one of the environment variables is called path, right? There are some other environment variables as well, like user. Okay, and I will be learning about this environment variable as well. And inside these environment variables, you will be having some value, right? So let's say for the path environment variable, you are having this value. So you can see this is a path, right? So user, local, bin, and these are multiple paths actually, and they are separated by this colon. So when you are running any command, the first thing it will do is it will look into this path environment variable, and from this path environment variable it will look for the location, right? First it will search in this directory the first location, and if it does not find the command here, let's say we are talking about ls command, so first it will look into this user local bin directory. If it does not find that, then it will look into this user slash bin directory. If it does not find it here as well, then it will just keep going into the next and next to next directories, right? Now let us open our terminal window and let us try to see those environment variables those are present, right? You are already familiar with this command echo, and if I type anything, any string number or whatever you want, it will just echo back that to you, right? Now with this echo command, you can echo out the content of any variable as well. To do that, you have to prepend the variable name with a $sign. So there's a variable environment variable called path, you already know. So I'm just typing path. Okay, so if I hit enter now, you can see this is that path variable, and these environment variables are editable as well. Like you can set whatever value you want, right? So that's why this is a long list of location you can see, because over the time I was using my system, so I have added a couple of paths from myself as well, and we'll be learning that part in a moment. All right, so this is a long list of paths, and I have in this diagram I have just shown you like a subset you can see. So for my system, when I'm running this ls command, first it will look into this directory location. If it does not find it here, then it will look into this location. If it does not find it there as well, then it will keep looking. So once it will find that ls command, it will take out the code and it will just execute. And to know the proper location of any program, there is a command as well. So that is which. So if you type which and the command name, it will just give you that path. So the ls command is present inside this bin directory, right? And this path, this bin /bin is present here as well. So this is that bin /bin path, right? So when you are running this ls command, it will look into, first it looked into this directory, this directory, this directory, and finally inside this /bin directory it found that ls file, and it loaded that ls file's binary, and it has run that command, right? You can run this which for all the commands that we were learning so far, right? So let's say I am running this which command for mkdir. Okay, it will just give you the location for mkdir. So this is how your shell knows like where to find out this program that you're mentioning. So if I just type something, some random characters and hit enter, it will tell you that the command not found, because it went through all the directories, but it did not find any file called this random characters, right? That's why it is saying command not found. All right, now let us actually go to this bin directory and let us see what are the things that are present inside this bin directory. So let me clear out and cd bin. All right, let me do a ls-l, and you can see all the commands are present here, right? So now what we want to do is we want to see the content of any of this command file, right? So these are simple files, okay, and containing some characters or bits, you can say. Okay, so to do that, let me use this cat command and cat ls. So this is a simple file, and how do you know that this is a file? In the left you can see there's a dash. So if it was a directory, then you would be having a d here, but as it is a simple file, you are having a dash here. So I can cat this file. So if I run this command, you can see like these are some, like these are not human readable characters, so this is just for machine. So these are the binary for this ls command. So I think now you know how things are working under the hood. All right, so in this video, let us discuss about some of the commonly used commands, right? So the first one is date. So date will just give you like whatever the date is and current timestamp as well, and my time zone, right? Then there's a command called uptime, and uptime will tell you like this system last time when did you restart. So for my system, I have started my system 17 days ago, right? So uptime will tell you that. So when you are managing different external cloud system, maybe this command might be helpful. All right, then there's a command called users, and users command will show you the users that are present inside your current system, right? There's a command called who, and who will give you the information about the currently logged in user. And you already familiar with this who command, I guess. And then there's a command called uname. With the uname command, this will give you the system information. So right now I'm on a Mac, and Mac is based on Darwin. All right. So if you are on a Linux system and if you run this uname command, then this will tell you about the distribution. Okay. So these are a couple of important command. If you want, you can memorize this, no problem. Now, to know about the disk space, we have a couple of commands as well. So the first command is disk free, or df for short, right? So if you type this command df and hit enter, this will tell you all the like drive that are, let me just maximize the screen so that you can see it properly. Let me clear out and run the command again. So df, right, disk free. Okay, so this will show you the file system, like whatever disks are mounted in your system. So you can see like on the root in the device, so these disks are mounted, right? Then it will show you the users, how much available space are there, all those information. And right now it's just showing you in byte format. If you want to know in human readable format, you can just pass this -h. You are already familiar with this. So yeah, if you pass this -h option, then you will get all the information in gigabyte or megabyte format. And this is a whole file system level command. So it does not matter from where you are running this command, it will give you the system file information. Okay, so this is disk free. Next comes the disk usage. So that is du. Okay, so if you type this command, this will like in the current directory. So if you do not mention any file path or anything, it will just show you in the current directory what is the space you are taking, and it will give you like all the directory. Like if inside this cat directory also, if I have any other directory, it would list that as well, right? And for this command as well, if you want, you can pass this -h, and that will give you this nicely formatted file size. Okay, so unless otherwise you are mentioning anything, du will be just giving you the current directory. And if you want, you can mention the directory path as well. And right now it's not showing you the file size. So to know more about the file size, what you have to do is you can just pass this star. So let me pass this with star, and that will give you like for all the files as well. And if you just want to know about a particular file, like how much space that is taking in your disk, then you have to mention the file path, right? So in that situation, du human readable, let's say for this file 2. Okay, renamed. Perfect. So it will just give you a single file. And by default, if you're not passing anything, then it will just take the current directory. Okay, and there's another thing that is, let's say when you are dealing with this du, let me cd into my root directory. All right, so here if I publish this du command, you can see like my system will crash because there are so many nested directories, right? So this is kinda impossible to see everything. So let me just clear out everything. So what you can do is you can mention the max depth. Okay, so what do I mean by that? So du human readable, and you can pass this d flag, and I'm just passing that, just give me 1 level depth. Okay, so that will give you, yeah. So these are, I don't have the permission, so I can, let me just quit out from the process. I'll be showing you how to quit out from the process as well. But yeah, for some of the things I don't have permission, I have to run this command with sudo, right? So the thing I want to show you here is, let me just go back to a desktop directory. That will make more sense, I guess. So if I do du -h and -depth 1, okay, so this will just give you like inside animal there's another directory called cat, so it is not giving you that size. Okay, so in a single level, whatever directories are present, it will just give you the size of that. All right, so if you pass 2 here, then it will take the cat as well. Okay, so you got my point. Like you can mention the depth here. So these are a couple of kind of important command you might use this time to time. Alright, so in this video, we'll be starting with a new topic, that is processes inside operating system. So let us understand process. So process are nothing but when you are running any kind of program, right? Whatever time it's taking, whatever resources it is taking, right? Combining those things, we're just calling it a process. right? So to understand that, let us take the example of that ls command, right? We had this diagram before. So you are typing ls in your terminal window and you are hitting enter. So then it is going to the shell. According to the environment variable, shell is finding out the command from the file system, like the binary. Okay. And once that binary is found, then it is running that binary, right? So this step, this execution step, is when the process is running, right? So the shell has started a new process. Now for this ls command, it's a very quick process. So it's just listing out all the things that are present in a directory. So it's a very quick process, right? So that's why within a couple of millisecond, you are getting the response and the process is done and it is just giving you the output, right? Now it's not necessary that every time when you are running something that within a millisecond you will get the response, right? There are some ongoing processes as well. So from a graphical user interface, let's say this draw.io software I'm using, right, to making these diagrams. So to run this program, this draw.io, I'm running a process inside operating system. So when I'm running this ls command, same thing, like I'm running a process, right? So there can be many example of processes. So if I give you an example of ongoing process inside terminal window, let's say when you are opening the Nano editor, right, with a file, or where you are doing some changes or something like that, at that time you are having a ongoing process, right? But for most of the time, all the programs that we are running in the shell, those are kind of like very fast processes. But the main concept is inside the operating system, basically we're running a lot of process, and those processes are using your CPU and GPU. And some of the processes have a very short time, short, like they are just quickly getting executed and giving you the output. And some processes are taking a long time to complete, right? And some process will have some interactivity with the user as well. So this is a perfect example, like this drawing software. I'm interacting with this software, right? I'm creating these shapes and all these things. For the Nano editor as well, you're writing, right? So those are some interaction that is happening with the process from the user side. So this is process. Now we'll be understanding a couple of commands inside terminal to see what are the process that are running, what are the process that are running by this current user or current session. Those kind of things we'll be understanding now. So in this video, we'll be discussing about some of the commands that you'll be using to know the details about the processes that are currently running in your operating system, right? So there's a very common and simple command that is called ps, or short for process. So if you run this command, it will just give you for this particular user. So currently I'm logged in as Shovan, right? So for this particular user and for this terminal session, what are the process that are currently running, right? So you can see there are currently two processes. So there's a login process. So during the login, it has started this process and it has included some like more context, you can say. I'm not exactly sure about this queue term as well. So it has started another process, right? So for a terminal window, if you're not running anything, then by default, two processes are running for this particular terminal window, right? So I can open another tab or another window. So I have opened another window, and now if I run this ps command, you can see I'm having two processes, right? Four processes basically, two per terminal window. Okay, so let me quit out from here. So this is basically process. Now if you are running this ps command or process command without any flag, then it will just show you all the processes that are running inside this terminal by this user. But you can pass some flag as well, and the flag is a. And you can see I'm not passing any kind of dash here, right? So basically process is a old command, and in previous days inside Unix, so inside BSD Unix particularly, they didn't have any kind of dash in front of the flag, right? And some of the commands nowadays also does not have any kind of dash in front of the flag. So process or ps is one of them. Okay, so if you pass this a flag, this will show you all the processes for all the users. So if any other user is using any kind of processes, it will show you that as well. Okay, the list is kinda big, so it is just giving you four processes, right? And if you want to know the username as well, then you have to pass it this u flag, so au. Then it will give you this username as well. So you can see there's another user called root, but the root user started these processes. There's another flag that is super helpful, that is AU. AU is for all the users, and you, like if you pass this U flag, it will just give you the username. And there's a super important flag that is X. So X will give you the details about all the processes that are currently running in your operating system. Does not matter that is related to this terminal window or not. Like right now I'm running this terminal window, there's a timer going on, or there's a screen recorder, my graphical user interface. So these are all processes, right, that are currently running in my operating system. So if you are passing this X, then it will show you all the processes. So let's publish this command. So ps aux, and you can actually remember this combination. So whenever you want to know something about the processes, by default you should, or you will be running this command. So ps space aux. Okay, so these are all the processes that are currently running. Let me maximize my screen size. Okay, so you can see, so there's a Windows Server user, and there are many, and it will show you the command as well when the process has been started, right? The CPU uses for that process as well. So there are many processes currently running. Now there's another command that is called top. Okay, and top will basically give you the real-time representation of the processes that are currently running. And I'm not changing anything, right? You can see it is getting changed by itself. So if you are running top, then it will just give you the top processes that are taking your CPU, right? So right now you can see this, there's a software, a screen capture software, that is taking most of the CPU. And sometimes the Windows Server is taking a lot of CPU, right? And for all the processes, there's a state as well. And you can see some of the processes are in running state, sleeping state. And yeah, so many information you can get from this top command. And this is a live dashboard. You can see all the things, and a lot of information about the CPU uses, about the like RAM uses, those kind of things. Okay, and if you hit Q, it will just quit out from that. So this is how you can use the top command and the ps command, obviously, to know about the processes that are running inside your operating system. All right, so in this video, we'll be understanding some of the state that a process can have, right? So you already know the running state. So when the execution is happening, that is the running state, right? And when the process is done, that's the over state, you can say. And there can be an in-between state, that is the sleeping state. So sleeping state means the process is kind of running, but it's not utilizing a lot of CPU. Okay, you can call it a sleeping state maybe. So a proper example can be when you were using the Nano editor to write something. So if you're not interacting with the editor, and if it's just sitting there, so that's kind of a sleeping state. And we are having a dedicated command to sleep for a couple of seconds as well. So if I open my terminal window and type the sleep command with some seconds, maybe for 5 seconds I want to sleep the terminal window, right? So you can see now I cannot do anything. So the process is running, and after 5 seconds, it is releasing the thread, right? Or the CPU. Okay, so this is sleeping command. Now let us discuss how you can quit out from a process. So let's say the process is sleeping, or it is in the running state, or that there can be third state, that is hanging state. Hanging state means the process got stuck. There's a bug in the software or something like that. So inside Windows, you open the task manager to quit out from the program or the process. And inside Mac, there is a similar thing. So you can opt in for this force quit, right? So yeah, now let us understand how you can quit out from a process. So there are a couple of options. The first one is let the process finish. So if you can see here, like for sleep, if I run this sleep command with 3 second, 2 second, I can wait for 2 second and the process will be over automatically, right? So that's one way of quitting a process. And then there's a queue. Like if you are reading a document with the less command, then you can press Q and it will take you out of that process, right? You can press Control Q for some of the program, Control X, escape button, right? So these are gracefully quitting out from a process, okay? And then comes the force quit. Now force quit means like if the process is hanged, right? It's not responding or doing nothing. At that situation, you can just press Control C to force quit out of the process. So let me give you an example. Let's say you are running the sleep command for 10 seconds, right? Now if I press Control C on my keyboard, you can see it is quitting out from from that process. And one more thing is, if Control C is not working, then you can try with Control D as well. Sometimes it works with Control D. Okay, but most of the time Control C will force quit. All right. And fourth option can be, you can try to close out the window, right? So by pressing here, if you're on a Mac or in the Windows, the control will be on the right side. You can just close out the window, and that might quit the process. But the problem is, for some of the processes, just closing the window does not kill the process, right? In the background, the process will be running. Okay, so this is not a very good option. And finally, there is a command called kill, right? So with this kill command, we can quit some process, right? So now let us understand in great details like how to use this kill command, and we will be passing some different flag to gracefully quitting out from the process or to forcefully quitting that process. All right, so now I'll be learning about this kill command, right? So if you're having any kind of process that is running in background, and we are having a lot of process in the background, so let me show that to you. So you already remember that to list all the processes that are currently running in your operating system, you have to publish this ps command, and let us pass this aux flag as well. So these are all the process. Now if I maximize this window first so that you can see it properly. All right, so there's a thing called PID, right? So PID is short for process ID. So whenever you are running any kind of process in your system, the first thing your operating system will do is it will assign a process ID. So there are many processes, you can see those are running in the background, right? And those processes has the process ID. So to kill this process, you need this process ID. So remember that. And there can be another use case, that is if the process is not responding, but most of the situation you will be using your task manager, or for Mac, as I have shown you already, this force quit feature to quit out from the process. But mostly you will be using this kill command to kill the background processes. Now kill is a heavy word, but it's not like you are always forcefully killing the process or terminating the process, right? So basically, when you are running this kill command with the process ID, it will send that running process a signal, right? So let me bring out my pen here. It will just send a signal. So it will send a signal to this execution process or the process, right? Now let us understand this signal. There can be basically three types of signal. The first signal is that immediately it will tell the process that whatever you are doing, stop everything and just terminate. I don't have any time, you have to terminate now. Okay, so that is kind of forcefully killing the process. And the second type can be, it will ask the process that whatever you are doing, just finish that up. If you want to save anything to the memory, or if you want to do any kind of cleanup process, finish that and then kill the process. So that is kind of a gracefully killing out a process. So from the graphical user interface, whenever you are closing the window by pressing this cross icon, that is kind of gracefully quitting out from the process, right? Maybe it will ask you like, do you want to save the file somewhere or not? But if you are forcefully terminating the process, and there are multiple commands for that as well, then it will just immediately kill the process. No time. Okay, no memory cleanup, nothing. And most of the time, you will be just gracefully killing the process. All right, so these are two most used signal that you'll be using. Okay, the first one is sigterm, or short for signal termination. And the integer, there is an integer value. So when you will be using this signal, you will be passing this integer value, and I'll be showing that to you in a moment. But the thing is, when you will be passing this 15 or sigterm command, or signal termination command, or signal termination signal, sigterm signal, basically, it will tell the process that whatever you are doing, just gracefully shut down. If you want to save anything or clean up any kind of memory, free any resources, do that and then quit out. And then this signal kill, or sig kill, and the integer value is 9 for this. And if you pass this -9 flag or sig kill signal, then it will tell the process that whatever you are doing, just stop it right now. You don't have any time, you don't have to clean up anything. Okay, you just terminate the process. Okay, so this is the two most used signal, you can say. There's another one that is sig up, I guess, and if you want to restart the process, then you will be using that. So let me go back to a terminal window. Let me clear things out a bit.
Okay, now the command is kill, right? Now let us do one thing. Let us run the sleep command, and we'll be sleeping for 20 seconds. Okay, and actually you can run this process in the background. I'll be showing that to you in later section, but yeah, for now let us open another window. Perfect. And if I run this ps command, you can see there's a sleep command, and that is already done, right? So 20 seconds has passed. So if I type ps now, you can see there is no sleep command. So let me sleep for, let's say, 100 seconds. All right, so let me clear here and run this ps command. Now you can see there's a process that is running, and we have this pid, okay, 1 on 797, right? So if I run this kill with this 1 on 797, okay, and hit enter, it will, like by default, it will terminate the process. This one, sig term. So by default, it is passing this -15 command. So like this -15 and then the process id. Okay, right now this process is not running, so it will just tell you no such process. So let me run the process again, and let me clear out and have the process id. So this time this is the id. So now let me explicitly pass this 15 flag, so that is just gracefully terminate the process, and the process id. Perfect. Hit enter, and it is terminating the slip. Okay, let me run it again, and this time we'll be forcefully killing the process. So again ps, this is the process id, and let me clear out. Okay, so kill, and this time just pass -9, right? And let me pass the process id and hit enter. Now you can see the message is different, right? It is killed sleep, like whatever command you have used in your terminal, right? And previously it was terminated. So this is the main difference right now for this small command. Like you cannot tell any difference because sleep is not like not saving anything to the system, or it's not, there is nothing to gracefully shut down. So termination and the kill command is acting exactly similar way. But for some of the commands, you should use this kill flag with -15, or by default it will take the 15. And if that is not responding, or you want to forcefully stop the process, then just remember this. So kill -9 and then the process id. So if I do psaux now, so there are a lot of important commands that are running, right? So I would suggest you do not randomly copy a process id and just kill that process id. So that might crash your system, right? So this is the concept of processes, and how they are running in your operating system, and what are their state, and how you can gracefully or forcefully kill any kind of process. All right, so in this section, we'll be discussing about the data flow for a command. So when you are running any kind of command, most of the time you are giving it some input, and the command is doing some sort of processing with your input, and it is giving you some output. Okay, and this input is called standard input or stdin, right? And generally you use your keyboard for the input device. And we'll be learning like there are some other way of giving input to a command as well. And the output is called standard output, and by default the standard output is your terminal window. Like whatever command you are running, it is giving you some output, you know already. Like when you are running ls command, it is like printing all the directory files name, and it is printing that on the terminal window. So by default, standard input or stdin for short is the keyboard, and standard output is terminal window. And in previous days, as already we have discussed in the first lecture, I guess. So in previous days, the standard input was typewriter machine, and the standard output was the printer. All right. So this is, I'm talking about the pre-monitor era. Like there are no screen for the computer, right? All right. So this is the concept of input and output for a command. So the standard input, if you're not mentioning anything, then that will be your keyboard. And the standard output, if you're not mentioning anything, by default, that will be the terminal window. For example, if we talk about this cat command, right? You already know, like for the cat command, we are passing this file path as an argument, right? So if I hit enter, it is showing me all the content that are present inside this file one. Now, here we are passing this
as an argument, but if you want, you can pass this as an input as well. So to show that to you, let's say we just run this cat command, but we do not pass any kind of argument here, right? So if I hit enter now, you can see it is just like the process is not over. It's in the idle state, right? It's expecting some sort of input from you. And as you didn't mention any kind of other input, it is expecting by default, it is expecting the input from the keyboard, right? So you can just type whatever you want. So let's say hello. And if you hit enter now, it is just echoing back that to you, right? So this is the output it is giving you on the terminal window, and this is the input you have given from the keyboard, right? So let me quit out, and you already know to quit out from a command, you just use Ctrl C. Now let me show you another syntax, that is cat and left angle bracket and again file1.txt. So if I hit enter now, you can see we are getting the same output as this. Now there is a subtle difference between this command, like this way of running the command and this way of running the command. That is, here this file1.txt, you are passing it as an argument to this command, right? Similar to like when you are running the echo command, right? Echo, you pass some argument. Okay, so in the similar fashion, you are passing this file path as the argument. But when you are using this left angle bracket, okay, remember, then you are just passing this file as the input to this cat command, right? So this is the syntax. Now, it's not necessary that all the commands that we saw so far will receive some sort of input. Some of the command does not. Let's say if I want to use this echo command, which is same structure, it is not giving you anything, right? Because after echo you are not having anything, that's why it's just giving you an empty string. Okay, so for echo you have to pass an argument to get some output, because echo does not accept any kind of input, but some of the commands are accepting input. Like one example would be cat. So in the upcoming videos, this concept will be super important. So when I will be introducing you to the pipe concept, right? So just for now, this is the concept. For input, you use this left angle bracket. Conversely, if you want to output anything to somewhere, you want to use this right angle bracket. Now, what do I mean by that? So let me clear out. Let's do an echo and echo hello. And if I hit enter, I'm getting hello. So if I'm not mentioning any kind of output destination, by default it is outputting to the terminal window, right? So just to check, let's do it like this. So hello, and in this time, let us have this output symbol. So that is right angle bracket, and let's have a new file called output.txt. Okay, or just output, right? If I hit enter now, you can see it has created a new file, and let us see the content of this file. So cat output, and you can see that's hello, right? So the main concept is, with this right angle bracket, you can redirect the output wherever you want, right? If you do not mention any kind of output destination, then by default it is outputting to the terminal window. But in this case, we are saying with this right angle bracket, the hey echo command, whatever output you are having, just redirect the output to this output file, right? So basically with this right angle bracket, we can redirect the output to a file. Now let us do it like this. So hi, and again output, cat output, you can see it has replaced the whole content. So this is the thing, if you are using a single right angle bracket, then it will replace the whole content of that particular file. If the file does not exist, then it will create a new file. But if the file exists and it contains something, then it will just completely overwrite the content. And there is a workaround for that as well. So if I do it like this, so echo hello, or let's call it second line, okay? And this time, instead of just having a single right angle bracket, let's have double right angle bracket, right? So same thing, output, and hit enter. And if I now cat the thing, so cat output, we can see we're getting appending the second line. All right, so this is a very important concept. So when you are redirecting the output to a file, you can just use a single angle bracket to overwrite everything from that file. Or if the file does not exist, then it will create the file. But if you want to append the thing to the file, then you have to use this double right angle bracket. So whatever commands we have discussed so far, like let's say this ls command will like list all the elements that are present in the directory, right? So we can redirect this output to a file as well. So let's run this ls-la, and this time let's redirect this to maybe ls output. Okay, if I hit enter, you can see nothing was getting printed on the terminal window because we are redirecting the output. And if I let me clear first. So if I cat ls output now, you can see this is the content. Okay, or I can open it from my GUI as well. So this is the content. So this is the concept of standard input and standard output and how you can manipulate that. So for standard input, you will be using the left angle bracket, and for the standard output, you will be using the right angle bracket. So in the upcoming videos, I will be showing you a couple of more concepts regarding this, so you can combine different commands. So let us come back to the next video. Alright, so in this video, we'll be starting with the concept of pipes. So let me just show you the syntax first, and it should make sense. So pipes is basically represented with this vertical bar, right? So on a QWERTY keyboard, on this backslash button, like if you shift press this backslash, then you will get this pipe symbol, right? So you will be using this pipe with two or more commands, right? So basically command 1, then pipe, command 2. That means whatever output that the command 1 is having, that will be the input of command 2. Now what do I mean by that? So let me just quickly open my terminal window. So you already know there is a command called psavx, right? So this is to get all the processes that are currently running, right, in the system. And you also know there is a command called less, and less will give you the paginated format of a big text, right? So less, and there's a big file present here. So you can see I can have it like this, and if you press Q, then it will be quitting out. Now we can combine these commands actually. So how to do that? So we first run the first command, so psavx, and we pipe that output to the input of this ls command. All right, or cat command. Let's just go with the ls command first. So now you can see I'm getting this paginated format. All right, and if I press B, then I can go backward as well. And if I hit Q, then quitting out. So this is the concept of piping. So if any command is expecting any kind of input, then you can pipe that input from another command's output. Let me give you some other examples as well. So there is a file called people.txt on my desktop, and if I cat this people.txt, you can see there are 4 names present in this file, right? So in my shell, there is a command called sort, right? That is used to sort different text or number, right? So I can do it like this. So cat people.txt, and whatever output I'm getting, I'm piping that to this sort function, okay, or sort program. So if I hit enter now, you can see I'm getting a sorted list, right? So let me edit this people.txt, and let's say add this Bob twice, okay, and let me exit out. Perfect. Let me clear and cat people.txt. Now we are having Bob twice, okay, and there's another command that is unique. Oh, sorry, unique, not QUE. So this unique command will basically strip out all the like repetitive names or values, right? So I can actually combine multiple commands with this pipe. Let me show you how. So instead of passing unique first, let me first pass the sort and then unique. All right. So now what I'm doing is whatever output I'm getting from this cat people.txt, I'm piping that to the sort command, and whatever output I'm getting from the sort command, that is I'm piping to the unique command. Okay, so if I hit enter now, you can see I'm getting a sorted list and there is no repetitive value as well, right? So this is how you can combine multiple commands, and the motivation behind the Unix was this. Okay, so they wanted to create something modular. So for a single task, so let's say this is a task, so you want to sort some things, right? So in previous days you had to write a complete program for that. So Unix was built to solve this kind of problem. So they had created simple programs, right? And with the help of this super powerful pipe operator, you will be combining those small program and you'll be solving large problems, right? So this was the main motivation behind creating Unix. So in the starting video I already mentioned, like, Unix was built for modularity, right? So yeah, and this is how you can achieve modularity inside Unix with this pipe command, and this is super powerful, right now I'm just showing you some silly examples, but yeah, we'll be learning for real world use case for this as well. Okay, so in this section, we have learned this right angle bracket that will be used to redirect the output from any command to a destination, right? And this pipe will be used to redirect the output from a command to a command. And this left angle bracket was used to give the input from a source. There is another command that is called grep, right? And you will be using this grep command with this piping operation a lot. Now, let me show you how. So let's say again, I'm running this PSAUX to see all the processes that are currently running, right? So these are all the processes. Okay, now whatever output I'm getting, I want to know, like, what is the login operation? What is the login operation? Like, I want to see that process, right? So the option number one is you have to go through line by line and find out the login operation. Okay, and they have some process description here. Yeah, this command. So from that command, you can find out the login. Okay, but this grep command, grep is regular expression search inside Unix, right? And this is a super powerful command, right? So let me clear out, and now we are running PSAUX, and whatever output I'm getting, I am piping that to this grep command. Okay, and grep will receive an argument, and that argument will, you will be passing the like that term you are searching as the argument. So let's say I'm searching for login, right? So grep login. So if I hit enter, you can see these are the commands that I'm having that has this login. Okay, so this is that login process, first to login process, and also this command as well. Like I'm running this grep login, it is giving you that grep command as well. So this is a super powerful use case, like real world use case of this piping command. So you'll be finding out different processes and different things. So let's say you are having a huge large log file, right? So using this grep command, and grep receive some flags as well. So with the flag you can modify different things. So for example, let's say we are having this people file, right? So let me cat this, so cat people.txt, and the output I want to pass it to grep, right? And we are searching for Bob. So whatever line that has matched with this Bob, it is just giving you that. But if I pass it like this, so by default grep is case sensitive, right? So if you want to do a case insensitive search, then you have to pass this flag I, and you can look for yourself. So there are many flags, so you can like modify the behavior of grep. All right, so this is how you can use pipes to combine different commands. While we are on this topic, I want to show you something very interesting, right? So that is called a null device. So null device. So there is a very special location in your file system that is called null device, or black hole, you can say, right? So what do I mean by that? So the location is, first of all, that is dev/null, right? So let me show you how to use this. Okay, so let's say I'm doing another cat operation with this people file. So as expected, it will just give you all the output on this standard output, right, on the terminal window. Now I want to send this output not to a file, but this dev null. Okay, this null device. Now what happened is, whatever output I'm getting from this command, I'm just redirecting that to nowhere. So this is called a nowhere, black hole. So this is lost, completely lost. So whatever output we got from this command, we are redirecting them to some like black hole kind of thing. Okay, you cannot find out the output later. Okay, now why this is necessary? So sometime if you're running any kind of cron job, or let's say any kind of process is running continuously and it's generating log, and you don't want to store the log and you don't want the output in your terminal window as well, then you can do it like this. So you just run the command, and whatever output the command is giving you, you are just outputting or passing that output to this dev null. Okay, so this is the concept of null device, you can say.